Columbia, Houston, we have you through TDRS. How do you read?
Reading you loud and clear, Tammy.
In Columbia, we have you the same.
Mission Control, Houston at 23 hours, 36 minutes mission elapsed time. We're now taking live television from the Delta camera in the payload bay of Columbia. The orbiter is nearing the western coastline of Australia, just north of the Argidee station.
Houston, Columbia.
Go ahead, Dave.
Yeah, we have the flight deck camera on, and it isn't pretty, but and there'll probably be some blockages. We drift back and forth in front of it, and we're not going to chase all the light leaks to get all the glare out, but you're free to have at it if you care to.
Okay, Dan, thank you.
This view from the flight deck, of course, we're seeing over the shoulder of Commander Dan Bridenstine, beyond him, Bonnie Dunbar. They're into the pre-deploy activities for the CENTCOM satellite. CENTCOM deploy upcoming now in an hour and 5 minutes.
In Columbia, Houston, we are taking flight deck video at this time.
We've cycled back to the Delta camera on Columbia's payload bay. Looking down on Australia, they've just experienced sunset directly below Columbia, and we believe those flashes we're seeing are thunderstorms down below on the Australian continent.
Houston, Columbia, we're going to start pulling the first pin in about a minute.
Okay, Dave, we copy and we'll be watching.
Payloads Officer Ben Solari reports we see the first motion of retention pins. The aft pivot pin has now been retracted. There are several pins which have to be retracted in order to set up the conditions by which we may march into the final payload deploy procedures.
In Columbia, Houston, we understand you're very busy preparing for the CENTCOM deploy. However, when you get a chance, we would like you to rerun MAL 2.8 alpha on the tags.
Okay, we'll give it a try.
Thank you.
This is Mission Control, Houston, now 53 minutes to deploy of CENTCOM. We see motion on the second pin. That's a forward pivot pin. They'll be pulling it out to about 100% fully retracted. Right now they're at 17% and slowly climbing. Aft pivot pin is 99% out. Forward pivot pin is now at 64% retracted.
Houston, Columbia for tags.
Go ahead, Marcia.
Okay, I'm going to show you what it's doing. If you can you see this picture of this crumpled up piece of paper?
Marcia, we can see it. You might want to try bringing it a little closer to the lens.
Okay, it's all accordioned up in there, just like you say it would be. And I clear that out, and then there is a whole, then there's a plain piece like this that has to be surgically removed. And then I've just sent two pieces through it on the advance, and I'll keep doing it till it's white if you want.
Okay, Marcia, that sounds like a good plan to us, and let us know when you get a piece of white paper out. In Columbia, Houston, for your information, it's been the high-resolution uplinks that have been causing the problem with tags. The photograph seems to be what hangs us up.
Okay, well, we can get along without pictures if that's what it takes.
Mission Control, Houston, the discussion underway having to do with the text and graphics system. had a couple of jamming problems since we launched. They're finding that in one particular mode, we experience the highest chance of getting jams, and that mode has to do with sending photographs. And as there's a lot of time involved in clearing the jams, if we can't figure out a way around that, for his part, the commander, Dan Brandenstein, volunteers they can do without pictures. So that may be a plan of action if that helps. Also, the forward pivot pin is now fully retracted. The keel pin is now in motion, and it's out to about 30% now. The final pin retraction will be the push-off pin. It's Mission Control Houston. That concludes our pre-deploy television downlink. We've gone into blockage on the KU. We were watching the crew for about a third of an orbit as they were in the procedures leading up to the CENTCOM deploy. Right now we have 3 pins fully retracted. The keel pin is now out to 100%. The last one will be the push-off pin. Deploy upcoming in 41 minutes. This is Mission Control Houston.
Houston, Columbia with a drive time report.
Go ahead, Dave. We're ready to copy.
Okay, Tammy, the aft pivot took 5 minutes, 10 seconds. The forward pivot pin took 4 minutes, 44 seconds. And the keel pin took just less than 5 minutes, but as you probably saw, and as expected, we got the A out indication first, and then we had to go over to the B side motors to get the B out indication. And so it's probably just a little less than 5 minutes before we got the first A out indication on that. And our plots all looked pretty linear.
Dave, we copy those times, and thanks for the report. In Columbia, Houston, we have your predicted time for push-off pin to 49% when you're ready to copy.
Go ahead, Houston.
Dave, the predicted time to retract the push-off pin to 49% is 152 seconds. That's 2 minutes, 32 seconds. I'll copy.
Houston, Columbia, we're ready to copy the predicted time to 49%.
Columbia, Houston, we're with you on UHF. How do you read?
You're loud and clear, Tammy.
Dave, the predicted time to 49% is 152 seconds, or 2 minutes, 32 seconds.
Copy, 2 minutes, 32 seconds to 49%.
Dave, that's a good readback.
And Houston, we're going to take away the in-cabin while we aim the cameras and whatnot.
Okay, Dan, thanks for the heads up.
Control Houston, less than 24 minutes now remaining until the deploy of CENTCOM. The Columbia should be maneuvering shortly to the deploy attitude, and in the time between now and 10 minutes prior to the deploy of the payload, Flight Director Al Pennington has stated his intention to go about the room, poll the flight controllers, and get a go for retraction of the final push-off pin and also the go for deploy. Columbia now maneuvering to the deploy attitude. That's a procedure that'll take about 9 minutes. Communications will now be handed over from the western to eastern satellites. CENTCOM deploy upcoming 19 minutes and 20 seconds from now. This is Mission Control Houston. 1 day, 0 hours, 32 minutes. Mission elapsed time. Deploy upcoming in about 11 minutes. The Columbia almost to the deploy attitude. At that point, when we see the ship reach that place in space, Capcom Tammy Jernigan will voice up the mission control go for final pin retraction and SYNCOM deploy.
In Columbia, Houston, the SYNCOM customers and the flight team give you a go to continue final pin retraction and deploy.
Can we copy a go for the final pin retraction and a go for deploy?
And the payloads officer reports motion on the final pin, the push-off pin. That pin now up to 11% retraction. About 9 minutes, 10 seconds now to deploy of SYNCOM. Push-off pin now at 42%. Time to deploy, 7 minutes, 45 seconds. Time to ignition for the separation burn, 22 minutes, 42 seconds. Mission Control Houston, the push-off pin now 97% retracted. Time to ignition, time to deploy, 4 minutes, 53 seconds. Time to ignition of the separation burn, 19 minutes, 51 seconds. And the push-off pin now completely retracted, 100% out.
Houston, Columbia, we've got all the pins pulled. We've got out indications under all the A and B columns, and we've got 2 up deploy pre-arm talkbacks.
Dave, we copy and concur, and you are go for deploy.
Copy, go for deploy.
Mission Control Houston now 2.5 minutes from deploy of SYNCOM, all very quiet here, and at least very little, if any, air traffic from the orbiter, so we assume they're deep within their checklist as they prepare for the final series of switch throws that will send SYNCOM on its way toward geosynchronous Earth orbit in about 2 minutes and 11 seconds. The ignition of the separation burn will follow 17 minutes from now. Also, 45 minutes after deploy, the SYNCOM perigee kick motor will fire off. We always maneuver the orbiter to a window protect attitude. On missions where we have an arm aboard, we will unlimber the arm, cradle it over the side, and try to take a look at the PKM with the wrist camera. We'll try to bring that to you live as we have good TDRS pointing angles at that time and should be able to acquire a KU signal. So we hope to take that television. It's not reflected in your TV plan, but we hope to take it at 13:41 Greenwich Mean Time, or about 45 minutes after deploy. Now about 1 minute, 10 seconds from deploy of SYNCOM, and all still go here in Mission Control and aboard Columbia. Mission Control Houston now 7 seconds from deploy of SYNCOM. Standing by for a report from payloads and the crew. Payloads Officer Ben Solari confirms good deploy.
And Houston, we had a good deploy. I'll get back to you about 80 seconds.
Dave, we copy and congratulations.
The crew member's busy right at the moment copying down exact times for the history books as they record the various switch throws and when SYNCOM left the bay. They're also taking a great deal of pictures at the moment. We're about a minute post-deploy. The ignition burn will take place a little less than 14 minutes from now. That's the ignition for Columbia's separation maneuver. 45 minutes after deploy is the ignition for SYNCOM's perigee kick motor.
And Houston, we have motion on the Omni.
Dave, we copy motion on the Omni.
And that's good news. That's the omnidirectional antenna, which automatically deploys itself shortly after the SYNCOM leaves the shuttle payload bay.
And Houston, it looks to us as though the Omni is fully deployed.
We copy.
Full deploy of that omnidirectional antenna is an indication of the good health of CENTCOM as it leaves the vicinity of the Shuttle Columbia. Mission Control Houston, the GNC officer reports Columbia now maneuvering to the set burn attitude. That'll take about 5.5 minutes to get to that attitude. The separation burn ignition upcoming in 11 minutes 25 seconds.
Houston, Columbia, when you're ready to copy, I've got a deploy time and our attitudes and rates.
Dave, we're ready to copy.
Okay, the deploy time was 1day/00:43:39er. And on page 3-13, the attitude and rates, I'm just going to read straight across. For current roll was 108.80, 207.87, 324.01. Reading across the rates, plus 0.001, negative 0.001, and plus all balls.
Dave, we copy. Thank you.
Tammy, that looked real pretty, too.
Dave, we concur, and the CENTCOM folks and your flight control team would like to say congratulations to the entire crew.
And the entire crew acknowledges that, and we say thanks in return.
We'll pass that along.
It's Mission Control Houston. We're now 7.5 minutes from the time at which we deployed the CENTCOM satellite, and about another 7.5 minutes from the time where Columbia will fire up and perform a 18 foot per second Delta V burn to separate from the that part of space where CENTCOM is located, in anticipation of the PKM burn that CENTCOM will do. Flight Director Al Pennington was observing...
Houston, we can see that the spacecraft is spinning up now. We'll try to get a closer look and see how fast it's going.
We copy, Dave.
And that was Mission Specialist David Lowe reporting CENTCOM appears to be spinning up now, which is the norm. The spacecraft is on an automatic sequence once it leaves the payload bay. It spins itself up and will, in about 38 minutes or so, fire off its perigee kick motor. Flight Director Al Pennington was observing that the LDEF people have probably breathed a sigh of relief. We now have an empty payload bay, he observed, and we intend to go fill it. That's one down, one more to go. The rendezvous with Long Duration Exposure Facility will next be the next large order of business. That, of course, will take place Friday morning. The latest update we have to the time of grapple with the Long Duration Exposure Facility is 3 days, 1 hour, 42 minutes, 57 seconds, or 8:18 a.m. Central Standard Time on Friday morning.
Columbia, Houston, be advised that we're off the tail. We're about 6 minutes from TDRS LOS. We'll pick you up on the west side at 107.
Roger, 107.
It's Mission Control Houston. Ignition of Columbia's separation burn will begin a little less than 2 minutes from now. We will go into a loss of signal period in 3.5 minutes. The CENTCOM perigee kick motor burn takes place 45 minutes after deploy. It's a little less than 38 minutes from now. The time on that burn, it lasts for 61 seconds. That's 61 seconds for the perigee kick motor burn on CENTCOM. Now 30 seconds prior to the separation burn Columbia is about to perform. Propulsion Systems Officer reports we're in a good configuration. We're about 1.5 minutes from loss of signal through TDRS East. This burn nominally is 18 foot per second burn. later today, 1 day, 2 hours, 30 minutes mission elapsed time, will perform what they're calling an unsep burn to nullify whatever rates are introduced in this particular maneuver relative to our rendezvous with LDEF. Propulsion officer reports we're burning and it looks good.
Houston, Columbia.
Go, Columbia. Go ahead, Columbia.
Lost the signal through the eastern satellite. We had a bit of data towards the end of that teacher's pass as the burn was underway, and both the propulsion officer, the flight dynamics officer, and the guidance, navigation, and control officer were all happy with the rates and the performance they saw as Columbia went over the hill, Tidris East. Our next television event on NASA Select, some unscheduled television made possible by your friendly INCO officer. We hope to use the wrist camera on the remote manipulator, and as the arm is cranked over the side, we hope to take some live views as the wrist camera takes a look at CENTCOM's perigee kick motor burn. It should take place over Tidris West on orbit 17. The duration of that perigee kick motor burn again is 61 seconds. And this is Mission Control, Houston.
Columbia, Houston. We're back with you through Tidris. How do you read?
Houston, we read you loud and clear and got a note for the RMS folks. I'm ready to do the PKM burn. When we brought up the arm, we did get a check CRT position for shoulder pitch. We don't think it's a problem, but we need your go.
Bonnie, we copy. You got a check CRT message for shoulder pitch, and we're checking. Columbia, Houston for Bonnie.
Go ahead.
Bonnie, you have a go to do an item 12 and an item 11 on Spec 94. We believe it's just a transient response.
Okay, being done.
Also, Bonnie, for your information, we expect to be in a good KU band attitude during the PKM monitor, so we'll be looking forward to watching it down here also.
Okay, we'll set you up.
Appreciate it.
Mission Control, Houston, the discussion between ground and crew as we came up over the hill on the western satellite had to do with what we believe was a transient response that the crew got as they were going through the motions to unlimber the arm and cradle it over the side to take a look at the PKM burn. We don't believe there's a problem with the arm. They've given Bonnie Dunbar a go to execute an item in the software to try to clear up the response they're getting on their cathode ray tube. It's Mission Control, Columbia now maneuvering to the window protect attitude in anticipation of the perigee kick motor burn on CENTCOM coming up in about 15 minutes.
In Columbia, Houston, we have a cleanup item for you on panel R13L.
I'm ready by R13L.
Yeah, Dave, you can go ahead and take your payload bay mech powers to off.
That's in work.
Mission Control, Houston, we're now about 11 minutes from the perigee kick motor burn on CENTCOM. Now a little less than 9.5 minutes from the perigee kick motor burn for CENTCOM. One possible change in our plan for later today to report. This is tentative at this point. We're still evaluating. The navigators and rendezvous and flight dynamics people have been looking at the relative merits of a couple of different maneuvers that Columbia might perform today. You'll recall our plan up to this point has been to perform what they call an unsep burn, later today at about 1 day, 2 hours and some minutes to nullify the rates introduced when Columbia separated from that part of space where LDEF is located. One of the things they're looking at is perhaps deferring that unset burn and then later in the day performing a NC burn. The net effect of that would be to put us in about the same posture relative to LDEF, but it would save us on the order of 30 foot per second of fuel. And on such a long flight, that's an attractive option. One of the things we're looking at now is how that change in plans might affect other systems and some of the secondary payloads aboard Columbia. Should that plan go into effect, of course, we'll let you know.
Columbia, Houston for Dave.
Go ahead, Tammy.
Dave, we wondered if you were able to determine whether or not the spacecraft spun up to 33 RPMs.
Tammy, the best count I got before we had our ohms burn was about 30 RPM. And then we had our ohms burn and we kind of got off attitude.
Okay, Dave, thank you.
And also, if you guys are ready to copy on page 3-14 of the CENTCOM deploy checklist, I can give you our heat reconfig numbers.
Dave, we're ready to copy.
Okay, again, reading straight across on the before column, it's 152, 164, 167. The after column, actually it's a row, 149, 163, 164. The MET of heaters on is 1/01:01:20.
Dave, we copy all that. Thank you.
Meanwhile, we're now taking live television from the wrist camera of the robot arm, the remote manipulator system, aboard the Columbia.
Columbia, Houston, we have some words for you on your unset burn planned for 0230.
Okay, Houston, we're ready to copy.
Dan, we have decided not to do the unset burn in order to optimize our rendezvous burn sequence. And we are going to replace it with an NC type burn at approximately 1 day, 4 hours. And we plan that will save about 30 feet per second. How copy?
Okay, Tammy, we're going to we're going to not perform the unset burn, but we're going to do an NC type burn at approximately 1 day, 4 hours.
That's affirmed, Dan. Also, when you selected DAP Bravo, we saw that the A contact failed low, and RM deselected that contact. However, you still have 2 of 3, and no impact and no action.
Okay, thank you.
This is Mission Control Houston. We're now about 1 minute from the initiation of the perigee kick motor firing. Again, that burn on CENTCOM is about 61 seconds long. The arm is pointed out over the side of the Columbia. Columbia's belly is now pointed in the direction of CENTCOM. And we hope to watch via this view from the wrist camera of the remote manipulator system live as that perigee kick motor fires off. Meanwhile, a decision has been made here on the ground in the interest of economizing our fuel usage to whatever extent we can do. We're going to go ahead and cancel the maneuver scheduled at 1 day, 2 hours, 30 minutes called the unset burn, and we'll defer and instead do a catch-up maneuver later today at about 1 day, 4 hours, 45 minutes, which will save us about 30 feet per second of gasoline. And we see a bright dot, or did see a bright dot at the top center of our screen, which was the initiation of the PKM burn. We're about 17, 18 seconds into the burn now.
Columbia, Houston, we recommend wrist yaw to track.
Houston, Columbia. We've been tracking with wrist yaw. We've got pretty high contrast on our monitor. We thought we caught the burn in a cloud, but we're not catching it anymore.
Bonnie, we copy. In Columbia, Houston, for Bonnie, the reason we made the call is we see wrist roll selected, vice wrist yaw.
On ground, you're right.
It's Mission Control Houston, still taking a live view from the wrist camera of the robot arm on Columbia. CENTCOM went that away. We, by all indications, had a good perigee kick motor burn. We were able to catch the first couple of seconds of that burn. And we're now looking at deep space, just past the limb of the Earth and the atmosphere of the planet, out into deep space. With this black and white camera, the stars show up a lot better.
Houston, Columbia.
Go ahead, Columbia.
Yeah, well, I couldn't get him. We tried, but we got a nice view in the end effector.
Bonnie, fortunately, we caught the beginning of the burn.
Yeah, we saw the beginning of it as well, but we didn't get it tracked out.
Hey, Bonnie, we copy.
It's Mission Control Houston. That concludes our view through the wrist camera aboard the robot arm on Columbia. An update for you. We hope to have a complete CENTCOM status report from our payload community within about the next 10 minutes, and we'll, of course, pass that along to you. Also, later today, in about 45 minutes or so, we'll plan to go ahead and have the change of shift press conference with off-going Lead Flight Director Al Pennington. Also, our satellite is now being fed and originating from Johnson Space Center, so viewers will be able to receive commentary on NASA Select, and your television signal should be standard.
Columbia, Houston, we've been experiencing some comm dropouts. We have you back now through TDRS East. How do you read?
You're loud and clear, Houston. Houston, Columbia, with some AFE words for you.
Go ahead, Dave. We're ready to copy.
Yeah, Tammy, Marcia and I were using that this morning. In fact, taking some, at the beginning, some pretty good pictures of my heart. Everything was working quite well. After, I'd say a half hour of the operating of the AFE itself, the top of the CRT, the top of the picture itself, became somewhat distorted. In fact, it was somewhat dynamic, and it appeared to sort of move off to the left. And in fact, as we let it go a little bit longer, sometimes we got completely horizontal lines on the CRT screen itself. It was about that time I started actually playing with the, or actually touching the box itself, and it was very hot to the touch. And so what I was thinking is that possibly some of the distortion that we were seeing in the picture was due to the unit overheating. What I've done right now is we've powered it down completely. I've actually pulled the unit about halfway out of its locker, and we're letting it cool down. And I guess we'll try to fire it up later, unless you guys have some other words for us on that.
Dave, we copy your report, and we'll take a look and get back with you. Columbia, Houston, we'd like a set burn report, please. We had some dropouts toward the end of the burn, and specifically would like to know what your final residuals are.
Roger, Houston. We had the burn, and everything was trimmed very low to below 0.2, probably an order of 0.1, with the exception of minus Z. That was 0.35, which, although you hadn't called us and told us it was a critical burn, we assumed since we ultimately are ending up in a rendezvous. So we put in two minus Z pulses to trim that down equal with about the rest of them.
Okay, Dan, thank you. That's exactly what we were looking for. Columbia, Houston, your Orbit 1 team has enjoyed working with you. Congratulations again on a successful SYNCOM deploy. We're handing over to Orbit 2 with Jim Voss and Steve Oswald.
Okay, well, thanks for staying up, spending most of the night with us, and we'll see you tomorrow.
See you tomorrow.
This is Mission Control Houston at Mission Elapsed Time, 1 day, 2 hours, and 1 minute. We're taking live television from the payload bay cameras aboard Columbia. This wide-angle color camera on the forward bulkhead, looking aft across the Ohms pod and tail as Columbia orbits high over the Atlantic Ocean, just off the coast of Cuba on orbit 18.
Houston, Columbia.
Go ahead, Columbia.
Yes, I'm powering down the RMS. I'm at the bottom of 4-4, and I'd like to know which heater you would like left on.
Okay, Bonnie, stand by and we'll make sure. Columbia, Houston for Bonnie.
Go ahead.
Yeah, Bonnie, we'd like for you to leave the A heater in auto and Bravo heater off.
Okay, thank you.
And just an explanation, we want to use the A heater during the first part of the mission, and then we'll use the B heater for the last half of the mission.
Houston, Columbia.
Go ahead, Columbia.
Understand you want B auto?
Negative, Bonnie. Right now, we want the port RMS heater Alpha auto and Bravo off.
Okay, thanks. We'll follow the procedure then.
Houston, Columbia, if you want to follow along, I'm going to begin reinserting the pins on the SYNCOM cradle.
Okay, David, thanks. We'll keep up with you.
This is Mission Control Houston. Our next television event on NASA Select Television today is a change of shift briefing with off-going Orbit 1 Flight Director Al Pennington. That briefing is scheduled for 9 o'clock a.m. Central Standard Time in the Building 2 briefing room here at the Johnson Space Center. That briefing will be carried on NASA Select via satellite for other NASA centers' participation. Again, the briefing will begin on the hour in just about 6 minutes at 9 o'clock a.m. Central Standard Time.
Columbia, Houston for Marcia on PCG.
Go ahead, she's listening.
Yeah, the PCG customer would like to have a little bit more information to help them in understanding what's going on with their secondary. So if you can, we would like for you to give us the times of PCG activation from door open and door close. You should have recorded those in the payload ops checklist on page 5.2, 5-3, 5-6, and 5-7. And then when you're ready, I'll ask for a couple of other things.
Okay, stand by. Okay, Jim, if you're ready, here it comes.
Okay.
PCG-2 operation was 4 hours and 27 minutes, and the temperature on the rim was 4 degrees. Tray 1 droplets were deployed at 4:33, Tray 2 at 4:35, Tray 3 at 4:38. Check the power again. Temperature was 4.2 and closed the door at 4:45.
Okay, we have a good copy on that.
And you want the PCG-1 numbers also?
That's affirmative, Marcia.
Okay, here they come. We started at 6:54. Temperature was 21.8. Tray 1 at 6:55. Tray 2 at 7. And Tray 3 at 7:07. And that's not right. Hold on. Yeah, that's right. 6 hours, 55 minutes, 7 hours, and 7 hours and 7 minutes. That's correct. And we closed the door at 8:15 after taking all the pictures, and the temperature was 21.8. And the number that I gave you this morning was 8 hours and 15 minutes was the last time we looked at it. And then when we came back to it this morning, we noticed it had been off. And the time that I looked at it, replugged it, was 19:32.
Okay, we have a good copy on that. Also, if you can recall, during post-insertion, when you reconfigured the PCG from MO13 Quebec to MO52 Juliet, if you can give us an approximate time that happened.
Okay, stand by. Bonnie will check.
And while she's checking on that, one last request is for the present temperature of both units, and if you happen to have recorded any other temperatures within the recent time period.
I've been keeping an eye on the second one. The PCG1 has been steady at about 21.8 the whole time, and I'll hold on number 2. Number 2 right now is 4.3.
Okay, we copied those. Thanks.
Houston, Columbia.
Go ahead, Columbia. Columbia, Houston.
Go ahead, Houston.
Yeah, we had a dropout just after you called us. Can you say again? Columbia, Houston. We've been having some comm dropouts. We're about to go LOS, and we'll see you on the other side at 2:43.
I'll see you then.
Columbia, Houston, we're back with you on Tidris West.
Hello, Houston.
And you were about to tell us something when we went AOS, or LOS.
Yeah, I think it had to do with the post-insertion timeline for changing the cables around for PCG.
That's affirmed. Do you have that information?
Yes, sir. That was performed in the post-insertion book, block 12, and the time was somewhere between 2 hours, 15 minutes MET, and about 2 hours, 30 minutes.
Okay, thanks a lot for the information.
Houston, Columbia.
Go ahead, Columbia.
When you decide that you'd like the deploy downlink, we'd like to have it configured for a camcorder, if that's okay.
Yeah, stand by just a minute.
Houston, Columbia for CENTCOM.
Go ahead, David.
Yeah, I've got the pins inserted right now, and I'm just about to shut the CEUs off. Just one other thing I'd like to point out before I put this away is that the forward pivot position has been cycling between 1 and 2, and yet I've got a good talkback on the back panel, and I let it run for the entire amount of time.
Okay, we copied that, David. Columbia, Houston, we're configured to accept your downlink of the camcorder if you're ready to send it to us.
Jim, I think that's going to be a few minutes. Stand by, please.
Okay, we'll be waiting.
This is Mission Control Houston. Our next television event on NASA Select is scheduled, some unscheduled shuttle television. Expecting to take a look at some onboard recordings of the deploy of the CENTCOM communication satellite. G. David Lowe and Bonnie Dunbar are setting up the camcorder to dump some taped color television of the deploy of that satellite. CENTCOM deploy went off this morning without a hitch. Deploy was on time, and the resulting, or the PKM burn to follow, as reported by the CENTCOM folks, was nominal at a burn time of 1 day, 1 hour, 28 minutes, 48 seconds with a burn duration of 61 seconds, resulting in a slightly lower than expected orbit, but well within limits. Everybody very happy with the results of the burn. This is Mission Control Houston. We're now looking at a live downlink from the crew aboard Columbia, sending us some pre-taped video from the camcorder. This is just prior to CENTCOM deploy. This is Mission Control Houston. These pre-recorded views being sent to us now from the crew of Columbia, showing the deployment of the Omni antenna out on the top of the CENTCOM satellite. That high gain antenna, a small thin wire protruding directly out between the two high gain antennas mounted on the top of the CENTCOM.
Columbia, Houston, we're enjoying a good downlink now from your camcorder.
Hey, Jim, how much of that did you see?
David, we saw the deploy and then just a little bit of the CENTCOM out over the Earth's surface, and we saw it repeated 4 or 5 times.
Okay. We didn't really mean for you to see it just then. We were just going over it ourselves. We might play it back one more time, and we also have some VTR for you, but don't configure for that just yet.
Okay, we will remain configured for the camcorder until you tell us otherwise.
Okay.
Columbia, Houston.
Houston, Columbia, go ahead.
Yeah, David, we're going to have a handover to the East Tidris, and we also have the ability to do a simulcast of your downlink. If you would wait until 3 hours and 20 minutes, that would be the best time for us. We should have the handover complete by then. So if you could send us your downlink production at that time, it would work out best.
Okay, Jim, we'll wait till 3 hours and 20 minutes.
Okay, and we're looking forward to it.
This is Mission Control Houston at mission elapsed time 1 day, 3 hours, 11 minutes. Columbia and crew on the ascending node of orbit 19. We're waiting for about 10 more minutes to look at some downlink television, which will consist of some pre-recorded views of the CENTCOM deploy, as well as some post-deploy tracking of the CENTCOM, and possibly some pre-recorded cabin TV. Again, we're expecting that in just about 8.5 minutes at mission elapsed time 1 day, 3 hours and 20 minutes. CENTCOM deploy went off without a hitch this morning. The deploy time was mission elapsed time 1 day, 0 hours, 43 minutes and 9 seconds. Sometime later, the perigee kick motor burn on the CENTCOM was affected and very well. The time of ignition for the PKM burn was 1 day, 1 hour, 28 minutes and 48 seconds. A full 61 second duration burn, placing CENTCOM exactly where it ought to be. All the CENTCOM folks are very happy with where CENTCOM's located right now, and controllers report that they have successfully commanded the attitude control electronics of CENTCOM on. This is Mission Control Houston. Mission elapsed time 1 day, 3 hours, 21 minutes. We're standing by for communications handover from the tracking and data relay satellite west to the eastern satellite, after which we expect to see some downlink television from the crew of Columbia, sending us some pre-recorded videotape that they recorded on their on-board camcorder, depicting the deploy of the CENTCOM communications satellite, as well as post-deploy tracking.
Columbia, Houston.
Go ahead, Houston.
You have an update on your IMAX target of opportunity. You can refer to message 4 Alpha if you'd like in your morning mail, but the bottom line is that the next site, the Caribbean Sea and Islands, scheduled for 3 hours and 39 minutes, is no-go because of clouds over the target.
Okay, Jim, we copy that. Site is no-go for weather.
That's correct, David.
And Jim, we're going to take the cabin fans off temporarily to clean the filters.
Roger, we copy that. Also, David, on your comment about the cycling of the forward pivot that you saw, that was just noise on the MDM like we had seen before.
Okay, Jim, thanks. And Jim, let me know when you're ready for the downlink.
Yeah, stand by just a minute, David.
Houston, Columbia.
Go ahead, Columbia.
Yeah, just a brief status. We're in the middle of FEA sample number 2 for disturbances during the treadmill, which will happen a little bit later on. And you can probably tell that Dan and Wex are doing filter cleaning. We'd like to go ahead and see if we can get the AFB back up and start taking some measurements, if that's okay with you.
Okay, stand by just a minute, Bonnie. Columbia, Houston for Bonnie.
Go ahead.
Yeah, on AFE, we'd like for you to hold off on that for just a minute. We're putting together some procedures that should be ready real soon with respect to your CRT problem.
Okay, thanks.
And for David, we'd like for you to hold off on the downlink. We're in the process of a handover, and then we'll be in KU blockage. We would like for you to be ready to do your downlink at 3 hours and 35 minutes now.
Okay, we'll wait till 3:35.
This is Mission Control Houston. Admission lapse time, 1 day, 3 hours, 30 minutes. We're still standing by to have a look at some downlink television depicting the deploy of CENTCOM, and are in the process of conducting some tests in the handover procedures of the ground stations handing over from TDRS East or from the western satellite to the eastern satellite. So it'll be at least another 10 or 15 minutes before we expect to see some more downlink television. Flight controllers here in Houston spending quite some time discussing alternatives for troubleshooting the problems with the text and graphics system. The electronics problems that were encountered yesterday have been solved, and today we're finding some paper jamming problems when images are being transmitted in mode 2, or the high resolution mode. In the high resolution mode, the paper travels more slowly through the text and graphics system on board, and whether or not that correlates to a real problem or not is unknown. So at this point, a strategy is being devised to try and determine whether we have a paper moisture problem or whether there is an actual problem in the system in that slow rate mode.
Columbia, Houston, I have some words on the tags when you're ready.
We're ready, Jim.
Yeah, David, because of the paper jams, we believe that's moisture in the paper. We'd like for you to take about 15 feet of paper off of the paper roll, and hopefully that'll prevent any future jamming. What we'd like for you to do is, using your cue card for the tags, do the paper loading procedure, but replace steps 5 through 12 with the following. Remove 15...
Okay, go ahead.
Okay, Marcia, I'd like for you to just remove 15 feet of paper from the roll and then cut the paper cleanly at 90 degrees to the edge.
Well, you must have read my mind, because during the deploy, when tags had quit working, I reloaded it and ran through 9 pages, and on the 10th page, it jammed itself, and I started it again, just got to the 10th page, and it jammed itself again. So I'll run off 15 feet and try it for probably the 6th time.
Okay, we're hoping that removing this amount of paper, it'll get rid of all the paper that has moisture in it, and then we'll be able to run it without jamming. Let us know what you find out.
Okay.
Columbia, Houston, when you get an opportunity, we'd like for you to give us a general status of how much stuff you were finding in the filters when you were doing your filter cleaning.
Okay, we will do that.
Columbia, Houston, we're back on the east satellite now, and we're ready for your downlink camcorder whenever you're ready.
Okay, that'll be 1 minute, Jim.
This is Mission Control Houston. We're standing by for some downlink television given us by the crew of Columbia, who are going to be showing us some pre-recorded videotape from their camcorder depicting deploy of the CENTCOM communications satellite. Expecting that downlink momentarily, and we're live.
And Houston, tell me when you have a good picture.
And we have a good downlink, David.
Okay, Jim, what you're looking at right now is the CENTCOM satellite. That's actually an acronym that stands for Synchronous Communications. It's built by the Hughes Communications Services Incorporated for the United States Navy. It's actually leased to the United States Navy for communications in the UHF frequency with its worldwide fleet. You can see it coming out of the payload bay right now, rotating at about 1.7 RPM and translating away at about 1.5 feet per second. It was held in the bay by a cradle. In the cradle, we had 4 pins that we released one by one, and then finally at deploy time, we had a pyrotechnic device that pushed it away. With the pyro device fired, and spring pushed it away at about 1.7 RPM. In this picture here, this is about 80 seconds into the deploy, and the Omni antenna you can see deploying at this time. As you can see, this spacecraft is actually deployed out of the payload bay when the payload bay is facing the Earth. It'll stay here. The next major event is at about 6 minutes, 35 seconds, and at which time some thrusters on the side of the spacecraft fire and spin the spacecraft up to about 33 revolutions per minute. The spacecraft will stay like that until about 45 minutes after deploy, in which time a solid rocket booster will fire, put it into an elliptical orbit, and then from there, some liquid apogee motors will fire and take it on up to geosynchronous orbit. And Jim, that's all that we had on the camcorder. We do have a little bit of the spin up on the VTR, and if you guys can get configured, we can show you that too.
Okay, David, we'll reconfigure now, and thanks for all the information with it as well. We'll let you know when it's ready.
This is Mission Control Houston. We're now just about 1 hour away from the next in a series of phase adjust burns or catch-up maneuvers, helping to close the approach rate between Columbia and LDEF. That burn preliminarily scheduled at 1 day, 4 hours, 48 minutes. By lowering one end of its orbit, Columbia will shorten its orbital period and allow it to, in essence, catch up to LDEF from underneath. That phase adjust burn was scheduled after canceling a previously scheduled unsep burn. Right now, Columbia is actually drifting slowly away from LDEF because of the dynamics of the separation burn following CENTCOM deploy. In fact, the opening rate at this point is drifting approximately 14 nautical miles per orbit, and this phase adjust burn, called an NC burn, at 4:48 will, in fact, put a halt to that closure and begin, or that opening rate, and begin closing again on LDEF at a more accelerated rate. All quiet on the air-to-ground circuit as flight controllers here in Houston continue to consider in-flight maintenance solutions to tags. A possible fix was formulated and called up in a procedure to Mission Specialist Marcia Ivins, asking her to roll about 15 feet off of the paper roll thinking that there might be some condensation or some moisture somewhere in the paper roll that was causing the jams. And by rolling that 15 feet out and recutting and resetting the paper, perhaps remedy the problem that we've had with paper jamming in the text and graphics system this morning. In addition to that, we've got weather folks and IMAX folks busily looking at targets of opportunity for shooting some IMAX film of the Earth today. We did have an opportunity that was scheduled previously over the Caribbean Ocean and looking at some Caribbean islands, but due to cloud cover in that area, that was canceled. We're expecting to see the startup of the American Flight Echocardiograph experiment here this afternoon. There were some minor CRT problems reported with that experiment this morning, but we feel like we've got those remedied, procedures developed for the crew to reconfigure that experiment, and we'll expect to hear more from that later on. Just a little while ago, Mission Specialist Bonnie Dunbar reported that they had set up the FEA, or Fluid Experiments apparatus, and conducted a data take in support of the MDE experiment, an experiment designed to study the effects of microgravity disturbances on the development of float zone crystal development. In fact, they set up the FEA and in conjunction with an exercise period as Commander Brandon Stein and pilot Jim Weatherby exercised on the treadmill. They set up the FEA and took the opportunity to look at what kinds of disturbances that exercise activity would create in the development of crystals in the samples. A second MDE data take is scheduled a little bit later this afternoon in conjunction with that phase adjust burn. One of the priorities of the MDE experiment is to study the effect of both crew and orbiter-induced disturbances on the development of crystals, and this phase adjust burn presents an excellent opportunity to investigate disturbances in that area. The Fluid Experiments apparatus that essentially is the experiment hardware that facilitates the investigations for the microgravity disturbances experiment is a modular chemistry and physics laboratory that fits in shuttle mid-deck lockers. It's used on previous flights and flights to come in conducting research in crystal growth, liquid chemistry, fluid physics, and thermodynamics. It has the ability to heat, cool, mix, stir, or centrifuge both gaseous and liquid and solid experiment samples. The FEA hardware is developed by Rockwell, and the Johnson Space Center on this flight has responsibility for having developed the material science experiments, the MDE experiment, and for analyzing the results of this flight. This particular FEA package is equipped with a number of samples, 7 samples of commercial purity indium in experiment ampules, which can be placed in the FEA hardware and removed.
Houston, Columbia.
Go ahead, Columbia.
Are you working on a pad for this burn coming up?
That's affirmative, Jim, and we're working on it right now. It should be here soon, and there's a tentative TIG time of 4 plus 48.
Was that 4 plus 28?
Negative 4 hours and 8 minutes.
Okay, we copy that, 448.
And we'll get that to you just as soon as we can.
Okay, thanks a lot.
The process of crystal growth and purification in the FEA involves the use of a heater that translates along the ampule that has the indium sample inside it, And as the heater moves along the ampule, more of the material, the indium underneath in front of the heater, melts. And as the molten material behind the heater cools as the heater moves along the ampule, it solidifies into a single crystal. And there's the presence of a little seed crystal at the initial solidification point, that the front end of the ampule, if you will, is planted there in order to facilitate the beginning of a crystal growth. The many industrial important materials cannot be successfully processed on Earth because of their properties, and the ability to grow these single pure crystals provide an opportunity to study the process of resolidification in these materials, providing greater insight into the development of some of these industrial materials. Essentially, the MDE investigation involves the operator, in this case Mission Specialist Dunbar, recording the mission elapsed time at the start of each of the ampule heater runs, and then significant orbiter maneuvers or other induced disturbances, such as the disturbance caused by the treadmill operation this morning, and then again another this afternoon as we conduct the phase adjust maneuver. There's an accelerometer that's attached to the FEA package that will provide measurements for post-flight analysis as well. Currently aboard Columbia, both protein crystal growth experiments are operating. PCG-1, which is designed to operate at room temperature, was activated on flight day 1 and has continued to operate at room temperature. PCG-2, which is designed to operate at a refrigerated level down, I believe, around 4 degrees centigrade, was interrupted in its operation at some time during the night. Crew discovering this morning that the power cable had been unplugged, and that since then the PCG-2 has been reconnected and restarted, and is now operating back in the temperature range that it was designed to, down around 4 degrees centigrade. Columbia continuing to perform very well. No major systems anomalies being pursued here in the flight control room. Columbia is now in a 193.7 by 169.7 nautical mile orbit. LDEF currently in a 183.6 by 176.7 nautical mile orbit. Prior to up until the phase adjust burn scheduled just about an hour from now, Columbia actually opening in distance from LDEF at a rate of about 14 nautical miles per rev due to the dynamics of the separation burn conducted after SYNCOM deploy. That opening rate is not unexpected, and there was a nominal unset burn scheduled to close the drift rate between Columbia and LDEF right after SYNCOM deploy, but that was deferred until later on this afternoon. We'll conduct a phasing burn with the object of beginning to re-increase the closure rate between Columbia and LDEF. And in the process of delaying that burn some, we will have saved about 30 feet per second in propellant. So by putting off until later what we could have done earlier, we have in fact saved some propellant that may come in handy later on in the rendezvous timeline.
Columbia, Houston, I have some words for you on FEA and AFE when you're ready.
Houston, say again, we had the vacuum cleaner running.
We have some words for you on FEA and AFE when you're ready to copy.
Okay, stand by. Okay, go ahead, Jim.
First of all, on FEA, During your NC burn, we'd like for you to perform FEA status for sample number 2 on page 3-18 of your payload ops checklist to capture the float zone disturbance on the camcorder plus 2 minutes of HISA data record starting 1 minute before the burn. And just an additional note, the DSO 476 will go as planned with a HISA recording time remaining at 40 minutes.
Stand by 1, Jim. Okay, Jim, we copy that you want us to do an FEA status 2 during the NC2 burn and catch that on the camcorder. Like 2 minutes of HISA on that starting 1 minute prior to the burn, and then you'd like to use the remaining time that we have on the HISA during the treadmill ops later on.
Yeah, that's affirmative, David, and it should still remain at 40 minutes for DSO 476.
Okay, copy. 40 minutes for 476.
And I've also got something on AFE when you're ready.
We're ready on that too.
First of all, on your video distortion, we think that may be due to electrical interference in the CRT driver circuit. What you can do when you reactivate AFE is look in the camcorder viewfinder after you put the camcorder to record, and you can see if that image is distorted as well. We'd like for you to reactivate AFE, and when you put the camcorder to record, let us know if you're still getting the video distortion on the CRT and if you're getting that same distortion on the camcorder viewfinder.
Okay, Jim, copy. You think it might be electrical interference on the CRT driver? We'll look in the camcorder viewfinder and see if we see the same distortion there, and we'll let you know what we see.
Okay, and then we may have some other things for you if we, depending on what we see when you do that. Then I have one other thing on the AFE high temperature. When you touch it, it should not reach the touch temperature limit of 110 degrees because of internal circuitry that'll shut the unit off before it gets to that temperature. We would like to verify the proper fan operation by having you do the malfunction 1.2 alpha on page 1-8 of your payload systems data malfunction procedure book. If you are getting exhaust air, we would like for you to check your inlet where the foam cutout is for any obstructions and verify that you've got good air passage on the upper left side. And if possible, because we've been having trouble with the AFE, we'd like for you to camcorder downlink the setup of the AFE so we can take a look at that as well.
Okay, Jim, we copy that. We'll take a look at 1.2 alpha, 1.8 on 1.8, and check the inlets. Now, just putting our hands around both sides, it felt like we had good exhaust. In fact, also we could feel some flow over the top portion right on top of the CRT there. There is what appears to be some holes that are taped over on the upper left side. There's a circular, what looks like an exhaust port that's maybe 1.25 inches in diameter, and then above that there is something that is taped over with some gray tape, some almost metallic type tape, and it's a whole bunch of holes that are taped over.
Okay, we'll take a look at that. Maybe you can get some camcorder shots of that also.
Okay, we'll try.
Though we are told that is the correct configuration with the tape over the holes, David.
Okay, I understand.
Columbia, Houston, we have a new orbiter state vector coming on board.
Okay, Houston.
Columbia, Houston, we will not be able to give you your burn pad before we go LOS, but we have got your maneuver load on board, and you are go to maneuver to the burn attitude, and we will give you your pad as soon as we get back on the other side at 421. And you will be using left ohms for the burn.
Roger, 421. Do you have the inertial attitude? Just so we can check it before you maneuver.
Roger, Jim, I've got your maneuver attitude is roll 206, pitch 089er, yaw 082.
Okay, thanks a lot. 206, 089er, 082.
Okay, and we'll give you the rest on the other side.
This is Mission Control Houston. We've just passed out of range of the tracking and data relay satellite east, due to acquire signal again through the western satellite in about 7 minutes. The burn was being discussed between the crew and the ground just prior to losing signal. There was the upcoming NC burn, or phase adjust burn, designed to help Columbia catch up in its closure on the LDEF rendezvous target. That burn coming up in about 34 minutes. We'll utilize the left orbiter maneuvering system engine, which will be straight fed from the left OMS pod fuel supplies. And we'll have more details on the duration and the effects of the burn as planned is when we acquire signal again through the western satellite. Also on this orbit, we offered some consultation with the crew on troubleshooting the text and graphic system problems that we've had with paper jamming in the tags, and have offered some advice on taking care of some problems with the American flight echocardiograph experiment this morning. The AFE is an experiment using a handheld ultrasonic measurement device that displays a scan of the subject's heart as a video image on a regular television screen. That data can be recorded on the onboard CCTV video tape recorder or on the camcorder on board. The crew is scheduled to take echocardiograph readings of the heart daily, and the problem encountered this morning was some distortion in the video display of the scan, and some procedures have been voiced up to the crew, and hopefully they'll be able to get the AFE set up again this afternoon and take care of the video distortion they've had in displaying that data. I don't think that there's, in essence, any problem with the data as it's recorded, but simply in the display mechanism used in conjunction with that experiment.
Columbia, Houston, we're back with you on the West Tidris, and we're ready to give you your maneuver pad when you're ready.
Loud and clear, and stand by. Okay, we're ready for the pad.
Okay, Jim, this is your maneuver pad for the NC2 burn. It'll be left ohms, TV roll 180, trim load, pitch -0.4, left yaw plus 5.2, right yaw -5.4. The weight 228,343. TIG 01/04/48:12.7. Peg 7 targets. Delta VX -017.8. Delta VY is all balls. Delta VZ -000.2. Maneuver attitude, roll 206, pitch 089er, yaw 082. Delta V tote 017.8, T-go 00:21, Vigo X plus 016.76, Vigo Y plus 003.61, Vigo Z plus 004.87. Target HA and HP is 183 and plus 169er. Notes, ohms gimbal check, post burn is left primary and right primary. RCS interconnect, right ohms to RCS. Down mode options is none. Your helium reg test is A, closed, B, open, and IMU deselect is not applicable. How do you copy?
Okay, Houston, I think we copied all that. It's a left ohms burn, TV roll 180, trim minus 0.5.4. The weight is 228343. Of 1 day, 4 hours, 48 minutes, 12.7 seconds. Peg 7 targets are minus 17.8. All balls minus 0.2. Attitude of 206. 089er, 082. Delta V total is 17.8. The T-go of 21 seconds. Vigos are X plus 16.76 plus 3.61 plus 4.87. Orbit will be a 183 by 169. Gimbal checks on the left primary when we're complete. Remain interconnected right ohms to RCS, no download option, and the regs are A closed, B open, with no IMU applying. Okay, and excuse me, I was right. The ohms gimbal check was left and right primary.
That's affirmative, Dan. Good readback on all of it, except we missed the trim load. If you could give that to us again.
Okay, it's minus 0.4 plus 5.2 minus 5.4.
And we'd also like for you to say one more time the readback on the weight.
Roger, the weight was 228343.
Okay, we have a good readback on all of it.
This is Mission Control Houston at mission elapsed time, 1 day, 4 hours and 30 minutes. We're about 18 minutes away from the NC2 burn, a phase adjust burn designed to lower the orbital apogee of Columbia from 193.7 nautical miles to approximately 183 nautical miles, and in the process accelerate the closing rate between Columbia and its target, the long duration exposure facility. It's planned to be a left ohms engine burn with a straight propellant feed from the left ohms pod fuel supplies. The time of ignition precisely will be 1 day, 4 hours, 48 minutes, and 12.7 seconds, with a total delta V of 17.8 feet per second.
Columbia, Houston.
Go ahead, Houston.
And Dan, since we're in DAP B right now, we would like at your convenience to hold the forward DAP Bravo button down for 5 seconds so that we can get some data from the little problem that we had before, and we'd like for you to give us a mark when you do that.
Okay, if you're ready to do it now, I'm ready.
We're standing by.
Okay, 3, 2, 1, mark. That Bravo button's in. There's 5 seconds.
Okay, thanks a lot. Columbia, Houston, just for information, Dan, the A contact is the one that we saw out before. All 3 contacts are good now, but RM, in protecting us, has taken out that contact, so we are just going to be continuing to work on 2.
Okay, thank you.
This is Mission Control. That last discussion between Capcom Jim Voss and Crew Commander Dan Brandenstein regarding electrical contacts on the digital autopilot B select button in an earlier selection of the DAP B. There was a failure indication on one of those contacts in the RM or redundancy management system aboard the orbiter.
With some more AFE words.
Okay, David, go ahead.
Yeah, Jim, Martian Bunny just reported that they got some good views. They cranked it up again and got some good views of Bonnie's heart. Toward the end of that, they started to see the same type of thing on the CRT display that we saw earlier in the morning, with the top portion of it starting to get skewed off to the left. Marcia took a look at that through the camcorder, and it looks perfect through the camcorder, so it does look like it's a CRT display problem itself. It had begun to heat up again, but it didn't heat up all that much. And in fact, we did this last run with AFE pulled out about 8 inches or so from the locker itself.
Okay, David, thanks for the information, and we may have some more words for you in a little while. How unreadable is the display when it starts skewing? Can you still use it, or do you have to use the camcorder to position the transducer?
The display is usable.
Okay, David, thank you. If you wind up having more problems with it so that you can't use it, let us know, and we'll have some steps for you.
Okay.
This is Mission Control Houston. We're 8.5 minutes away from the NC2 burn, and just got some good news from Mission Specialist G. David Lowe that the American Flight Echocardiograph experiment is configured and has been imaging the hearts of some of the crew members, and that the imaging through the camcorder system as well as the VCR system is working fine, that the image degradation that was encountered in earlier AFE runs appears to be a cathode ray tube or monitor problem, and should not impact the operation or the integrity of the data of the operation of the AFE. In addition, was with the assistance of Commander Brandenstein holding in the digital autopilot B mode select button, learned that the apparent failure indication that was received indicating that one of the electrical contacts on that selector button was faulty appear not to be true at all. The contact is working, but due to the transient fault message, the redundancy management system on board has deselected that contact and rendered it out of service. We're being protected very carefully by our redundancy management system on board. In this case, it wasn't necessary, but because of the redundancy in that system, there's no impact on that. We have 3 good contacts, and the digital autopilot B selector button works fine, and that autopilot mode will be available throughout the remainder of the flight. So with some loose ends being tied up with some of the mid-deck experiments on board, as well as the digital autopilot selector, we're counting down now at 6 minutes and 45 seconds to the left ohms ignition to start the phase adjust burn. Again, that's a left ohms burn, straight fed from the left ohms pod. At time of ignition is scheduled for 1 day, 4 hours, 48 minutes, and 12.7 seconds. Should give us a delta V of about 17.8 feet per second. The burn is designed to lower the orbital apogee of Columbia from a current apogee of 193.8 nautical miles to approximately 183 nautical miles. Orbital perigee will remain the same at 169. This maneuver will, in essence, shorten the orbital period of Columbia, allowing it to catch up from underneath to the long duration exposure facility. This burn is a burn which was not previously scheduled at this time. There was an UNSEP burn, an ohms burn, which was designed to take some of the drift rate out between LDEF and Columbia after the separation burn after the CENTCOM deploy. That separation burn designed to move Columbia away from CENTCOM in preparation for CENTCOM's perigee kick motor firing, and actually induced an opening rate between LDEF and Columbia. Very small as it is, it was an expected opening rate. It's approximately 14 nautical miles per orbit, and real-time calculations by our flight dynamics, propulsion, and rendezvous officers here in the flight control room determined that by deferring a burn and conducting a phase adjust burn later this afternoon, we would in essence save about 30 feet per second of propellant, and that's propellant that could be very useful later in the stages of rendezvous. So in the interest of conservatism and optimizing the rendezvous profile, we've scheduled this phase burn for this afternoon. We're just about 4.5 minutes away from ignition at mission elapsed time 1 day, 4 hours, and 43 minutes. This is Mission Control. This is Mission Control. We're just about 1 minute and 15 seconds away from the NC-2 burn. Prop officer here in the control room confirms that the vehicle is properly configured for the burn. Propulsion officer here in Houston confirms ignition and the burn's looking good. This is Mission Control. Propulsion and flight dynamics officers here in the flight control room both agreeing that the burn is complete and looks very good.
Columbia, Houston, we saw a good ohms burn, and information on your IMAX targets for Orbit 20, Mexico City, and Brazil both look to be no-go because of clouds.
Okay, we copy, thanks. And Houston, you want us back to our normal on-orbit attitude now?
That's affirmative, Dan.
Okay, away we go.
This is Mission Control Houston. Our coverage of the STS-32 shuttle mission will be interrupted shortly at noon Central Time today for a television event from NASA headquarters in Washington, D.C. Again, our next television event on NASA Select will be a NASA Total Quality Management Colloquium, a television event originating at NASA headquarters in Washington, D.C. This will preempt coverage of the STS-32 mission for a short time. This is Mission Control Houston. Our television coverage of shuttle mission STS-32 will be preempted for a short time while we bring you a television event from NASA headquarters in Washington, D.C. Again, our next television event on NASA Select will be a special event from NASA headquarters in Washington, D.C. That event will begin on the hour at noon Central Standard Time and will shortly preempt on NASA Select television coverage of shuttle mission STS-32. At mission elapsed time 1 day, 5 hours, and 20 minutes, this is Mission Control.
Houston, Columbia.
Go ahead, Columbia.
Yes, we're about ready to start treadmill. I knew you needed some advance notice for high wrap, and we're sorry that already started, but if you can give us about 10-15 minutes, we'll give you an exact start time when G. David starts running.
Okay, thanks. We'll let you know. Columbia, Houston, we would appreciate a status report on AFE, if you have that, and on the tags, if you took the paper off the tags roll.
Stand by. Okay, Jim, here comes the tags report. I've got 7 pages out of it now, and we're working on the 8th, waiting for the white one after I took the 15 feet off.
Okay, that sounds good. Let us know how it came out.
You'll be the second to know.
And I have some words on AFE.
Okay, we'd like to hear that.
Okay, we took one data take on myself using the combination of the onboard screen and the camcorder, and while it took a little bit to find the right views, the four-chamber being the most difficult, we think we got the data that we needed. As soon as we get configured here on the treadmill with G. David, I'm going to be doing Marcia, and then we'll try to catch other people as we can before bedtime.
Okay, Bonnie, and we'd just like to know how the CRT is doing. Did the skewing stay the same, or did it get any worse? Did you notice any difference in it?
I didn't see it the first time, but from what I understand, it wasn't as bad. We have the unit pulled out about 6 inches. It's staying a little bit cooler. We still had a question about that silver gray tape. It appears to be covering some holes, and we weren't sure if those were ventilation holes or not. This is on the left-hand side. When I used it, the only thing that was really skewing were the top 2 lines of letters, but they were looking okay on the camcorder.
Okay, and the tape over the holes is a nominal condition. That tape is supposed to be there. And if you see any degradation or changes in the view that you get on the CRT, we'd like to know that because it could show some other problems that might be developing. So keep an eye on that as you're doing it and let us know if you see anything different.
Okay, will do.
Columbia, Houston, Bonnie, we believe that the CRT skewing is due to EMI and should not be a problem. We just want to keep an eye on it in case it is something else. And I have an attitude that we'll want you to go to for a DTO when you're ready to copy.
Okay, go ahead.
Yeah, Bonnie, this is a DTO for a TDRS to TDRS handover while we're overlapping the 2 TDRS. And so we will need a special attitude, and that attitude is roll 2-4-9er, pitch 1-4-3, yaw 2-9er-5. We'd like for you to start that maneuver not later than 1 day, 6 hours, and 20 minutes to get you in attitude by the time we have the AOS of the TDRS at 6:35.
Okay, Jim, we copy maneuver of roll 2-4-9er, pitch 1-4-3, yaw 2-9er-5, and we'll start no later than 1 day, 6 hours, 20 minutes, and I assume that's A auto-burn.
That's affirmative, Wixby, and you can stay in this attitude until you maneuver to the IMU align at about 1 day, 7 hours, and 20 minutes.
Okay, we'll stay in that DTO attitude until we maneuver for the IMUs, 1 day, 7 hours, 20 minutes approximately.
Okay, good readback.
This is Mission Control Houston. That last discussion between flight controllers here in Houston and the crew aboard Columbia regarding a RCS maneuver plan to adjust the attitude of Columbia to provide direct line of sight pointing at both tracking and data relay satellites on the upcoming orbit in order to support a TDRS to TDRS handover demonstration, which is part of an ongoing effort to refine our procedures in handing over quickly and cleanly from one satellite to the next as the orbiter tracks through that overlap zone. Again, this will be a small maneuver just designed to orient Columbia's attitude to support that test using the RCS Vern jets.
Houston, Columbia.
Go ahead, Columbia.
Treadmill's in progress.
Okay, thank you for the heads up. And when you get an opportunity, would you mind giving us a shuttle particle monitor readout on the mini-RAM and the data logger?
Okay, stand by.
This is Mission Control Houston. We're just about 2.5 minutes from losing signal through the tracking and data relay satellite east. crew aboard Columbia operating the fluid experiments apparatus in support of the microgravity disturbances experiment. Treadmill operations are underway at this point. Crew members getting a little exercise and at the same time doing their thing for science as mission specialist Bonnie Dunbar watches the indium crystal growth process during induced activity in the cabin to see what effect the vibrations of and accelerations on the equipment due to the activity on the...
Go ahead, Columbia.
Roger, regarding the SPM, the mini-RAM reads decimal 00, and the data logger reads alternately 0.008, and sometimes 0.009er.
Okay, we copied zeros on the mini RAM and 008 and decimal and alternately decimal 009 on the data logger. Okay, thank you, and we're going to lose you in about 1 minute. We'll pick you up on the other side at 5:59, and you'll be talking with Oz when you come back.
Okay, copy that. And occasionally, by the way, the mini RAM reads decimal 01, but not very often.
Okay, thanks. We were just looking for a baseline on that so that we would have it for later. Thank you.
And by the way, if we still have you, the SPS number 1 and the SPM are both at the CDR's window right now.
Roger, Jim. Thanks.
This is Mission Control Houston at mission elapsed time 1 day, 5 hours and 55 minutes. For those listeners to Mission Audio, at this time we have some new relative figures regarding distances between LDEF and Columbia. As of mission elapsed time 1 day, 5 hours and 30 minutes, as a result of the most recent phase adjust burn, the NC2 burn, Columbia was trailing 764 nautical miles behind LDEF and closing at a rate of 35 nautical miles per orbit. This produces a new estimated time of ignition for the TI burn, or the initiation of the terminal phase of rendezvous, at 2 days, 23 hours, 42 minutes, and 29 seconds, which would give us a grapple time of 3 days, 2 hours, 13 minutes, and 29 seconds, or roughly 8:48 a.m. Central Standard Time on Friday. Again, figures just in after recalculations based on the NC2 phase adjust burn. LDEF currently 764 nautical miles ahead of Columbia. Columbia closing at a rate of 35 nautical miles per orbit. Calculations show an estimated time of ignition for the TI burn, which will start the terminal phase of rendezvous at 2 days, 23 hours, 42 minutes, 29 seconds, giving us an LDEF grapple at 3 days, 2 hours, 13 minutes, and 29 seconds, or roughly 8:48 a.m. Central Standard Time on Friday. We're currently out of range of the tracking and data relay satellite system. We should acquire a signal again through the western satellite in about 2 minutes and 30 seconds. Upcoming on orbit 21, we expect to see the orbiter in a new attitude, which is designed to provide direct line of sight pointing to both tracking and data relay satellites in the range during which they overlap coverage, in order to support a TDRS to TDRS handover demonstration. This demonstration is designed in efforts to further refine and perfect the handover procedures and techniques without losing substantial amount of continuity in communications as we hand over every orbit from TDRS west to TDRS east. Again, we're about a minute and a half now away from acquiring signal through the west satellite. At mission elapsed time 1 day, 5 hours, and 57 minutes, this is Mission Control.
Columbia Houston on TDRS West.
Loud and clear, Oscar.
This is Mission Control Houston at mission elapsed time, 1 day, 6 hours and 25 minutes. We're standing by to hear from the crew of Columbia on progress of the troubleshooting with the text and graphics system. Crew has completed the ejection of 15 feet of paper off the roll that's loaded into the tags right now, and are now in the process of advancing 10 pages, page by page, through the machine in order to set the stage for some attempts at commanding imaging from the ground. Also on this orbit in just a few minutes, ground controllers will be conducting a TDRS to TDRS handover demonstration test in efforts to further refine and develop the techniques and procedures used to hand over from satellite to satellite each orbit. Just prior to coming back onto NASA Select satellite distribution, Crew Commander Dan Brandenstein and pilot Jim Weatherby maneuvered Columbia into an attitude that will allow for direct line of sight pointing at both satellites once they're in the overlap range to support that handover demonstration. And we have some updated numbers regarding proximity between LDEF and OV-102 as a result of the phase adjust burn conducted earlier in the day, the NC2 burn. As of 1 day, 5 hours and 30 minutes, Columbia was trailing 764 nautical miles behind LDEF and closing at a rate of 35 nautical miles per orbit. The calculations after the burn show a new TI ignition time. TI is the terminal phase initiation, the burn which begins the final phases of rendezvous on flight day 4. That new time of ignition for the TI burn is 2 days, 23 hours, 42 minutes, and 29 seconds, which gives us an LDEF grapple with the robot arm at approximately 3 days, 2 hours, 13 minutes, and 29 seconds, or roughly 8:48 a.m. Central Standard Time on Friday. Once again, rendezvous planning being refined somewhat after the phase adjust burn and giving us some new numbers regarding LDEF and its proximity to the pursuing Columbia. Columbia now 764 nautical miles behind LDEF, closing at a rate of 35 nautical miles per orbit. This gives us a new terminal phase initiation burn at 2 days, 23 hours, and 42 minutes and 29 seconds, which gives us a grapple at 3 days, 2 hours, 13 minutes, and 29 seconds. That translates to roughly 8:48 a.m. Central Time on Friday, flight day 4. And we're standing by to hear from the crew aboard Columbia regarding their success or lack thereof regarding the troubleshooting they've been doing with the text and graphics system. Procedure called to the crew was to forward 10 additional pages into the tray after having pulled 15 feet of suspect paper out of the graphics system, and that'll set the stage for further ground commanding to the tags. Also, during the last hour or so, we learned that the American Flight Echocardiograph experiment has been in operation, and troubleshooting to rectify the problem with the display of the heart data did not entirely resolve the problem, but at least confirmed in the minds of investigators here on the ground as to the problem. Apparently, one half of the screen of the monitor that the crew is using to observe the heart imaging that the AFE scanner is providing is showing some distortion and is not, as it has been determined, has not been interfering with any of the data takes, the data that's being seen on the other monitoring equipment on board, including the camcorder monitor and other available monitoring devices. as well as on the VCR are intact.
Go ahead, Columbia.
It's the tags repairman. We've got 10 pages out, and the last one is white, and they all look good.
Okay, great. Thank you, Marcia.
And David's finished run on the treadmill. We'll give you a call when WEX starts so you can start the high wrap.
Roger that.
Good news reported by Marcia Ivins that 10 pages have been forwarded into the tray successfully without jamming or folding, and that the last one is white, indicating that it has not been exposed to light during the change out of the paper or the ejection of some of the paper in the tags, and that paves the way for our instrumentation and communications officer to begin commanding from the ground again.
Houston, Columbia.
Go ahead, Columbia.
The trusty POT is about to hit the road. So if you want us to fire up the high wrap, now's a good time.
Roger that, Dan. We'll do that.
This is Mission Control Houston. That last comment from Crew Commander Dan Brandenstein referring to pilot Jim Weatherby, who's about to hop on the treadmill and get a little exercise, both in efforts to condition the heart in order to help combat the effects of weightlessness and turn around once back on the ground, as well as to provide some data for the MDE investigators. The high wrap that Brandenstein referred to are an accelerometer package or packages that measure the level of disturbances in the microgravity environment as the FEA apparatus operates in support of the MDE studies.
Columbia, Houston, we've sent you another tags test message. When you get a chance, if you could check the tray for us, we'd appreciate it.
I already have it in my hand, and G. David's overjoyed.
Well, if it looks good, we're all overjoyed.
Yeah, I'll second that.
This is Mission Control Houston. That last air-to-ground exchange confirming that the previously sent test pattern page was received on board without any problems. That's good news.
Columbia, Houston, we see you just starting to get into some of the pre-sleep activity, and we have some flight notes for you on the pre-sleep.
Roger, you came in a little broken at the very end, but you had something for us to do in pre-sleep.
We've got your pre-sleep cryo reconfig and also a note on the right ohms.
Okay, go ahead.
Okay, after the fuel cell purge, we'd like you to configure R1 with O2 and H2 tank 1 heaters, Alpha and Bravo, 4 switches off, and O2 and H2 tank 2 heaters, Alpha and Bravo, 4 switches auto. And then the O2 and H2 manifold valves for tank 2, 2 switches closed with the talkbacks closed. And we will not require a water dump tonight. And on the right ohms, we need a repress for that. On panel 08, the switch is right ohms, helium press, vapor isolation valve, Bravo, open for 30 seconds, and then closed. And that should keep you from getting nuisance alarms overnight. And as a reminder, we'd like to get a brief description, if we could, on the condition of the filters post-cleaning today. And we also have another note. Andy Allen is maintaining the office tradition of the fighter pilots and their female offspring. He and Julie are the parents of a 6-pound and 13-ounce girl Her name is Meredith Francis. Was born around 1900 Central Standard Time last night.
Houston, Columbia.
Columbia, Houston. How do you hear?
Okay, loud and clear. You cut off right about the time you were talking about Andy Allen's tradition. Maintenance thereof.
Well, we had a little ground problem there, and we're still trying to figure out exactly what happened to us, but we're back. And Andy and Julie Allen had a little girl last night about 7 o'clock. She came into the world at about 6 pounds and 13 ounces. Her name is Meredith Francis, and Mom and daughter are doing fine.
Great, and we all send our congratulations to the new parents.
Okay, we'll pass that along.
Okay, on those, the manifold, O2, H2 manifold switches, I missed which ones. When it closed.
Okay, O2, H2 manifold valves for tank 2 closed, with the talkback closed.
Unfortunately, you cut out again.
Okay, manifold valves for tank 2. Tank 2, both the O2 and the H2.
Tank 2, manifold valves closed. Thanks.
You bet.
This is Mission Control Houston at 1 day, 7 hours, and 2 minutes into the flight of Columbia on STS-32. The crew is well into their pre-sleep period at this time, just a little under 2 hours away from putting the crew to bed after a very productive second day on orbit, which saw the successful deployment of a CENTCOM Navy communications satellite. That satellite was deployed nominally on time and is now where it should be located in orbit around the Earth prior to its liquid fuel engines burning the satellite back up to geosynchronous orbit from where it will operate. We had the opportunity to use the remote manipulator system, the robot arm, just after CENTCOM deploy in order to use the end effector camera to view the PKM burn, and operating the arm with no problems, giving flight controllers a warmer feeling that we have a very healthy robot arm to venture into our rendezvous and grapple and photo survey with. We've had a very clean vehicle, both on flight days 1 and 2. Columbia working very well. No major systems anomalies being pursued here in the flight control room or on the vehicle. Mostly minor disturbances or annoyances being dealt with. A bulky text and graphic system, which has been chewing up paper, has been wrestled with a little bit by removing some suspect paper from the graphic system and then resetting it. We've been able to successfully send test patterns to the system on board, and they're imaging well and advancing paper into the tray as it should now. Done a little troubleshooting with the flight echocardiograph experiment and determined that some of the distortions they'd seen on the display monitor of that experiment turned out to be basically monitor defects and having no effect on the data being collected, and there are other monitor options available on the vehicle using the camcorder monitor. All the mid-deck experiments moving along very well. The fluid experiments apparatus 1 and 2 both have been up and operating all day. The MDE experiment in conjunction with the FEA hardware was supported today with a few data takes in conjunction with an ohms burn and with some treadmill activity in the mid-deck, helping to understand a little bit more about the way induced disturbances in the microgravity environment affect the development of crystal growth and the development of crystals grown in a float zone. Number of medical DSOs, medical studies helping investigators back on Earth further their efforts to understand the physiological effects of zero gravity. And then late in the day, a rendezvous burn was conducted, a phase adjust burn, one that adjusted the upper end or the apogee of Columbia's orbit, lowering it somewhat to decrease the orbital period, or the time it takes orbiter to complete a revolution around the Earth, so that Columbia can begin closing in again towards LDEF. Columbia, as of about an hour and a half ago, was 764 nautical miles away. Columbia closing at a rate of 35 nautical miles per orbit. Again, everything looking very good for a Flight Day 4 rendezvous and retrieval. Columbia is now on the descending node of orbit 21 at an altitude of 183 nautical miles, currently at orbital apogee. Columbia now in an orbit of 183 by 169.1 nautical miles. LDEF some 700 nautical miles away in an orbit of 183.6 by 176.7 nautical miles. And we're about 1 hour and 51 minutes away from calling it a day and putting the crew of Columbia to bed, and handing over from the Orbit 2 team to the planning team, who will spend the evening preparing revisions to the Flight Day 3 timeline and just minor alterations. There are no major replanning tasks for them to conduct. At 1 day, 7 hours, and 9 minutes into the flight of Columbia on shuttle mission STS-32, this is Mission Control.
Columbia Houston, a reminder on the maneuvered IMU line.
Go ahead, Steve.
Roger, we see that maneuver needing to start at around sunset. It's a fairly large maneuver, so we'd like you to go ahead and load and maneuver to attitude.
Okay, Steve, that can work.
Houston, Columbia.
Go ahead, Columbia.
Okay, I'd like to give you a brief status on our experiments and medical DSOs.
Okay, you must be reading our minds. We were about to give you a call on that.
We just completed the treadmill, and Dan is getting ready to get on it, probably be 5-10 minutes. We've done AFB now on David, myself, Dan, and Marcia, and tomorrow we'll try to catch everybody. We think we'll have time to do that.
Roger that. Copy. You finished up with AFE, and Wixby's just finished up on the treadmill. And do you have any words on the sample number 2 FEA?
Yes, we're getting some spectacular data. It doesn't take a high-resolution camera to see it. I think it'll be useful for a lot of folks. We're finding that to keep our molten zone intact, probably around 50 to 55 watts is where we need to be. We're starting under that at about 48.
Okay, copy. That sounds great. And the MLE folks were looking for a few words on some video downlink that they saw earlier on in the mission at about 2340 MET.
What did they need to know?
They were just wanting to know whether or not you had recorded on MLE any of the lightning activity that they saw on the video downlink.
Houston, Columbia.
Columbia, Houston.
Go ahead, Houston. We lost you.
Bonnie, we lost the uplink there just momentarily, and we're going to lose you on the East Tidris here in about another minute. Why don't we pick up and chat just a little bit more about secondaries on the other side at about 7:37. Columbia, Houston on Tidris West.
Loud and clear, Steve, and do you need the numbers for the alignment?
That's affirmative, Wixby. You got that during LOS, so we'll need the numbers.
Okay, I'll read them to you in just a minute. And Houston, Columbia, if you're ready to copy.
That's affirmative. We're ready to copy, Wix.
Okay, and the minus Y tracker star 39, minus Z star 47, angular error 0.00. For IMU1, I'll read you delta X, Y, and Z. It was minus 0.06 plus 0.10 minus 0.19er. IMU2 minus 0.08 plus 0.04 plus 0.07. IMU3 minus 0.11 plus 0.05 minus 0.18. And the execution time was 1 day, 7 hours, 33 minutes, and 33 seconds.
Roger that, Columbia. We copied it all. Thank you. And Columbia, reminder... go ahead, Bonnie.
Go ahead with your reminder.
Bonnie, we were planning on doing the PMC on time as noted in the execute package at MET 7:45, if you concur.
Stand by. Houston, Columbia.
Go ahead, Columbia.
Okay, Dan has already started his exercise protocol, and he's ramping up. You can schedule the PMC on time, though, and the rest of us will be here.
Roger that. It sounds good. And if you like, we can finish the secondary status after the PMC.
Okay, we'll stand by after that.
This is Mission Control Houston. That last discussion between Capcom and crew aboard Columbia regarding the standard Flight Day 2 private medical conference, a secure discussion between the crew of Columbia and the flight surgeon here in the flight control room. During the time, Dan Brandenstein will be in the midst of his exercise routine on the treadmill. After the PMC has been conducted, we'll complete the secondary status report by the crew. So far, the crew has briefed the ground on the activities in support of the flight echocardiograph experiment, reporting that 4 of the 5 crewmen had been subjected to data takes for the AFE, and that they had getting a lot of good data in conjunction with the fluid experiments apparatus experiment. We're waiting to hear a little bit more on the CNCR bread mold experiment and on the protein crystal growth packages. And that should wrap up the summary of today's secondary experiment activities on board Columbia. We're about an hour and 15 minutes away from officially starting the crew sleep time, and the time at which the planning team should begin arriving here in the flight control room to relieve the Orbit 2 team and begin the alterations, minor as they are, to the Flight Day 3 timeline.
Okay, you can turn us back over to the mission control group.
Columbia, Houston.
Houston, Columbia.
You're loud and clear, Bonnie. And the question that we had on MLE before LOS was basically whether or not you had recorded any of that lightning activity that you downlinked to us on the video on either the camcorder or the 35 millimeter.
Stand by. Houston, Columbia.
Go ahead, Bonnie.
Yeah, Steve, we were in the middle of a bunch of other activities and just happened to catch that for the downlink. Unfortunately, we weren't able to get it recorded.
Okay, no problem, and I think that just about completes our secondary scorecard here, except if you have any IMAX information to pass to us.
No IMAX today. We'll do better tomorrow.
We figured y'all were pretty busy. Had a pretty full dance card. So we'll get that tomorrow. Thanks a lot.
Okay, and pass on to the film test guys that no film test today, but I'll make up for lost time. Not to worry.
Roger that. We'll pass it.
Houston, Columbia.
Go ahead, Columbia.
If it's okay with you, I'll do the KU band antenna cable positioning.
Roger, if you could hold off on just on that for just a bit. We've got a TAGS message coming up to you that has your traj for tomorrow.
Sure, no problem. I can hold off as long as you'd like.
Hey, Wixby, we'll give you a call when that message is complete. Columbia, Houston.
Go ahead.
Roger, trying to be consistent with G. David's methods of putting a crew to bed. We're planning on not talking to you here anymore the rest of the evening, but before we sign off, we've got a few notes for you. The first one has to do with circ pump 1, and you can expect to see that circ pump cycling about every 6.5 to 7 hours to maintain accumulator pressure. On the antenna cable positioning, you've got to go to continue with that procedure once you've seen the traj message in the tags tray, and that should be on board here momentarily. We're also planning on sending you a new orbiter state vector, and just a reminder to get the LIO change out before you go to bed to save us another call. And finally, status on the SYNCOM. SYNCOM is looking good. The PKM burn went well, and all systems are go, and we're waiting on the land burn. So congratulations on a great day and a SYNCOM deploy, and we're looking forward to a successful rendezvous tomorrow. You're currently behind LDEF by 697 miles and closing at 35 nautical miles of rev.
And Steve, we copied all that. Thanks for the good words. I guess the message just came up and jammed the tags, and we'll take a look at that. We will not forget the LIO, and we'll get to that eventually.
Roger that.
And I'll do the, I'll tell you what, I'll do the cable positioning now that we're troubleshooting the tags.
Yeah, roger that. And I guess so much for the plan for sending you guys to bed early here, but we'd like you to run the MAL 2.8 alpha on page 2-55 of the MAL book for the tags jam.
Okay, Marcia's intimately familiar with that one.
Hopefully we won't wear that page out before the mission's over.
Houston, Columbia.
Go ahead, Columbia.
Yes, did you command tags off?
Negative. We have not commanded tags off.
Stand by. Steve, I was going through my ACE unjam procedure, and when I went to turn the master power back on, I get no lights. Is that what's supposed to happen?
Marcia, let us chat about it down here for a second, and we'll have an answer.
Okay, well, I'm going to turn the master power back off again.
Roger, that sounds good. And you might be looking at the teleprinter. We're going to send you a backup copy of that TRAJ message. Columbia, Houston on the tags.
Go ahead.
Roger, we think we got caught in the KU cable positioning procedure. In order to get the tags power back on, we'd like you to take the KU to panel and power tags on, and then KU to command.
Okay, we copy that. And also, Steve, Dan is finished with his treadmill.
Roger that. Thank you.
Houston, Columbia, 4 tags.
Go ahead, Columbia.
I did all those 3 steps and there's still no lights.
Roger, understand. Still no lights. Let us go back and talk some more, and we'll have more words momentarily.
Okay.
Columbia, Houston for Marcia.
Go ahead, she's listening.
Okay, we'd like to basically repeat the same procedure that we just did, but first we'd like you to take the tags master power to enable, and then KU to panel, tags power on, and KU command. And hopefully that'll work better for us.
Okay, it's in work. Okay, Steve, that worked, and the first blank piece is coming out, and I'm going to go through it all over again for 10 and see what happens.
Okay, Marcia, sounds good, and we'll be waiting on the results. Thanks.
Houston, Columbia.
Go ahead, Columbia.
Yes, would you like the TVs on for Earth views?
Columbia, Houston, that's affirmative.
Okay, I'm going to give you camera D for a while. It's got some nice colors.
Okay, thank you very much.
Houston, Columbia, the cameras are yours.
Roger that, Columbia. And we had a couple of questions on the tags, Mal.
Go ahead.
Okay, I wondered if you could run us through the MAL, what blocks you worked in MAL 2.8 alpha, and whether or not you used the IFM tool to clear the jam, and exactly where the paper jam was located.
Okay, hold on. Okay, Steve, I went through block 1, 2, 5, and came out of 5 with a no. I knew it was jammed, and I used the tool that's got the real long neck on it and the little bitty grabbers. Probably half the time I've done this, I've had to take about a third of a piece of paper out from under the cutter bar, and the other times I haven't. It's always been accordioned before it gets to the cutter bar. And I downlinked that this morning on one of the ones that I did just to try to show you what it was doing. It has been identical every time, and it's been on about page 10, and I've been taking every page out as it comes through.
Okay, Marcia, thanks a lot. We copied all that, and we think we understand it, and we'll pass it along and see if we can't come up with something for you tomorrow.
Well, instead of sending us a test message, you ought to send us something real the first time, because it's always the second thing you send that jams it.
Roger, but the way Murphy's been working on this tags, it'd probably switch and jump on the first page that we send up next time.
This is Mission Control. Next expected shuttle television should be some payload bay views from the Delta camera in Columbia's payload bay. That's the wide-angle color lens. Crew aboard Columbia graciously allowing the ground to control that camera in order to take some exterior views of the Earth. That downlink coming up somewhat soon. We don't have an exact fix on what time we'll see that, but sometime in the next 4 or 5 minutes.
Columbia, Houston on Tetris East.
Go ahead, Houston.
We've been talking about tags down here a little bit, and we've run out of ideas and suggestions for tonight. We'll think about it overnight, and we'll have something for you in the morning. Basically, we'd like to put you to bed now. We'll be here for about another hour and a half, and then the planning team will take over, and they'll talk with you in the morning. So have a good night.
Steve, I'll give you a call when I get clear paper. I'm just sitting there and doing it page by page, and maybe doing it a little quicker will help, and I'll give you a call when we come up with a clear one, and then we'll quit. You want to send us something, that's fine. Other than that, we'll see you tomorrow.
No, I think we're going to punt for tonight, Marcia, and we'll try working with the tags again tomorrow morning. But we'll wait for your
Okay.
We'll wait for your call on the paper advances.
Houston, Columbia, I know you put us to bed, but I got one thing for you before. I just got off the treadmill, and I had a little bit of a problem with their data collection device, and I got a question for them.
Okay, Dan, go ahead. We're listening.
Okay, on Flight Supplement 1-28 in the med checklist, Step 5, after I got done running on the treadmill, I pushed the program button, which, and the display shows what it should have. And then I was just going about my business, cooling down and whatnot. And when I came back, probably about 15 minutes later to do step 6 and 7, it was just running as a clock, and the data doesn't seem to be stored on there. Step 7 would have me press enter, and then it would spit back the data, the heart rate data, and I was going to record it on a recorder. And I don't know if there's any way to march through these and get back to that data, if it's still in this little black wrist piece or not. And I guess I don't need an answer right now. What I'll do is just, you can have somebody try and track that down, and no one else will use this thing until tomorrow, and then tomorrow maybe we can still recover the data.
Okay, Dan, we understand the problem, and the medical folks are going out to look at that. If we get a quick answer, we'll be back with you. Otherwise, we'll talk with you about it in the morning.
Fair enough.
Houston, Columbia, bedtime call for tags.
Go ahead, Marcia.
Put 11 pieces through, and none of them jammed, and I guess we'll wait for tomorrow.
Okay, Marcia, that sounds good. Hopefully we'll have better luck with it tomorrow.
This is Mission Control Houston. That previously expected live downlink television from the payload bay of Columbia is not going to be a possibility before the end of this orbit. We've got about 19 minutes left before we pass out of range of the Tracking and Data Relay Satellite East, and we'll be in blockage from the KU band antenna on Columbia until then. So with the camera powered up in the payload bay and the ground in control, the next time we have some direct line of sight pointing between our Tracking and Data Relay satellite system and the KU band antenna, we'll have the opportunity to look at some live downlink television, but not at least in the next 30 minutes. All quiet here in the flight control room as Orbit 2 flight controllers are preparing messages and notes for the handover to the planning team, who's due here on console in about 10 minutes to begin a 1-hour handover. The crew aboard Columbia officially 13 minutes away from the start of their sleep period. We've already given them a good night and have no more actions for them today. All systems aboard Columbia very clean. Orbiter working very well. No major systems anomalies being looked at here on the ground or pursued on orbit, with the exception of a few minor distractions involving the text and graphics systems and some of the mid-deck experiments, which have already been resolved. Literally nothing inhibiting the accomplishment of mission objectives with the CENTCOM deploy this morning. CENTCOM is well on its way to where it belongs. Last we heard, the PKM burn was nominal, placing CENTCOM in its staging orbit for later liquid propellant burns, which will carry it to geosynchronous. At last take, Columbia was trailing some 690 some odd miles behind LDEF and closing at a rate of 35 nautical miles per orbit. The orbital apogee of Columbia now very closely matching that of LDEF, setting the stage for a final phase of rendezvous on flight day 4. And ultimately the grapple, photo survey, and berthing of the long-duration exposure facility. As of the phase adjust burn that was accomplished today, that NC2 burn, which lowered the high point of Columbia's orbit to allow it to continue to catch LDEF, gives us a start time for the terminal phase of rendezvous as 2 days, 23 hours, and 42 minutes. That's the point at which the TI burn will be conducted, which gives us an LDEF grapple estimated to occur at 3 days, 2 hours, 13 minutes, and 29 seconds, or roughly 8:48 a.m. Central Standard Time on Friday. Columbia now in the sleep attitude, pre-sleep operations completed on board. Just 10 minutes away from officially starting the sleep period, although the crew has already been given a good night. Ready to hand over to the planning team here for minor adjustments to the flight day 3 timeline. At mission elapsed time, 1 day, 8 hours and 49 minutes. This is Mission Control.
Columbia, Houston.
Go ahead, Houston.
And David, we just sent you another orbiter state vector update. You should also have message 8 alpha, traj message, came up on the teleprinter. And if you could pass to Dan, we've been talking about this medical DSO that he had a problem with. And basically what we'd like you to do is just go ahead and put the monitor on the shelf. Nothing will change overnight, and we'll have words for you in the execute package.
Okay, we'll, I guess, wait till tomorrow to hear any more about that. We did get that traj message, and we'll see you tomorrow.
Okay, sounds good. Columbia, Houston for Dan.
Stand by 1, Steve.
David, what we're looking for is to help out in the troubleshooting. If you could just read us exactly what the monitor for DSO 476 is showing at this time, that'd probably help us out.
Okay, we can do that. Okay, Steve, what the thing is reading right now is 4:37 p.m. and there's seconds of some sort below it counting up. That's probably what it is. It's 4:37:52. It's just that the time to the seconds is on 2 lines.
Roger that. I guess what they're saying is that is somehow reverted to the clock mode. What the folks are saying is that you can probably just hit program a couple of times. That ought to get you back to the memory symbol with the heart and put you back where you want to be.
Okay, I figured there was some way of doing it, but I didn't want to go stabbing in the dark, so that's why I gave you guys a call. Thanks.
Roger that. Hopefully that'll work for you, and we'll wait on the status in the morning of that. Folks, have a good night.
Okay.
This is Mission Control. Our next television event on NASA Select TV will be a change of shift briefing by off-going Orbit 2 Flight Director Bill Reeves. That press briefing scheduled for 5 o'clock p.m. at the Building 2 briefing room here at the Johnson Space Center. Again, next television event, a post-shift press briefing with off-going Orbit 2 Flight Director Bill Reeves on the hour 5 p.m. Central Standard Time. This is Mission Control. Our next television event on NASA Select is scheduled to be a change of shift briefing with off-going Orbit 2 Flight Director Bill Reeves. That event scheduled to begin at 5 o'clock p.m. Central Standard Time, originating from the Building 2 briefing room here at the Johnson Space Center. Again, our next television event, a post-shift press briefing by off-going Flight Director Bill Reeves on the hour at 5 p.m. Central Standard Time.
This is Mission Control Houston at mission elapsed time 1 day, 10 hours, 13 minutes. The crew of Columbia has now been in their sleep cycle for a little over an hour. The planning shift flight controllers are now on station here in the control center and settling in to begin updating the flight plan for the crew when they wake up tomorrow morning. In the meantime, our next television event will be a change of shift briefing with off-going Orbit 2 Flight Director Bill Reeves. That change of shift briefing will begin at about 5 p.m. Central Standard Time here at the Johnson Space Center. This is Mission Control Houston. Planning team now settling in for their evening's work and making changes to the flight plan to be uplinked to the crew when they wake in about 5 hours and 15 minutes. In handover from the Orbit 2 team, the vehicle was handed to this team very clean. Very few problems to report that are being worked, save for the text and graphics system, which had a paper jam near the end of the Orbit 2 shift. That jam was cleared by the crew, and during the shift this evening, planning team plans to send a message on the text and graphics system to see if that is working properly. Earlier today, the crew deployed the CENTCOM satellite for the Navy. That satellite is currently in an orbit of about 8,200 nautical miles by 164 nautical miles. All systems aboard that spacecraft appear to be working fine. Payloads officer reported that the satellite attitude control electronics have been activated, and that appears to look good. During the evening today, we plan on hopefully getting some TV downlink from the orbiter of Lightning, possibly during this pass over South America. That will be part of one of the payloads on board the mesoscale Lightning experiment. That experiment has flown on the last several civilian shuttle flights. Following deployment of the CENTCOM satellite earlier today, the crew did a separation maneuver from the satellite and later had scheduled an unsep maneuver, but that was deleted in favor of doing an actual phasing burn to help save on the margins for the actual rendezvous part of the mission on flight day 4, Friday. once the crew wakes up tomorrow, their activities will include, for the most part, conducting several of the onboard secondary experiments, including the fluids experiment apparatus, the protein crystal growth experiment. Hopefully getting some IMAX photography, none of which was able to be obtained today due to the activities related to the deploy of CENTCOM and unfavorable weather over some of the target sites that had been scheduled. So during the evening tonight, the team will be looking at some new targets that will be uplinked to the crew in their package that will hopefully get some good IMAX photography during the day tomorrow. Also planned are 3 more phasing burns. The NH burn, the NSR burn, and the NC4 burn, and those 3 burns will continue to bring Columbia closer to LDEF. Flight Dynamics Officer reported just a few moments ago that at crew wake up in about 5 hours and 10 minutes, Columbia will be about 522 nautical miles behind LDEF and closing at a rate of 33 nautical miles per orbit. That will be at crew wake up in about 5 hours and 9 minutes now. Currently here in the control room, Flight Director taking a weather briefing, a routine weather briefing that happens on every shift to give the team updates on the weather around the United States and at the other sites around the world. With 3 burns scheduled for the day tomorrow rather than 2, which had previously been planned, some of the activities in the flight plan will move around just a bit. Some of those include the fluids experiment apparatus status reports that the crew is scheduled to give, and also some of the exercise, aerobics exercise that's listed in the flight plan. Those will shift, and those updates will be sent up to the crew in their morning mail. This is Mission Control Houston. Our next television event could be coming up in about 10 minutes as we cross the coast of South America. We hope to be looking for some lightning in support of the mesoscale lightning experiment. However, it will be a real-time call as to whether we see any of that type of activity. This is Mission Control Houston. The television coverage that we thought we might get over South America won't come down due to the blockage of the KU band antenna on the orbiter. It can't actually see the tracking data relay satellite because of the position of the orbiter. Therefore, we won't be getting TV on this pass. JSC transmission of NASA Select will be interrupted shortly. Broadcast will resume at approximately 7:50 p.m. and therefore the next transmission may be non-standard. We will be giving the satellite to Landsat for approximately an hour and a half beginning at 6:20 p.m. Central Standard Time. This is Mission Control Houston, now about a minute away from losing signal with Columbia through the tracking and data relay satellite east. All continues to go very smoothly and quietly here on the planning shift. All controllers continue to prepare messages that will be uplinked to the crew when they wake up about 4 hours and 10 minutes from now. Columbia is currently closing on the long duration exposure facility about 33 nautical miles each orbit, and it's expected to be about 522 nautical miles behind the satellite by the time the crew wakes up. Columbia now just beginning orbit 25, And LDEF just beginning orbit 32,396. Currently at a mission elapsed time of 1 day, 12 hours, 21 minutes. This is Mission Control. This is Mission Control Houston, NASA Select now originating from the Johnson Space Center, all continuing to go smoothly on the flight of Columbia and STS-32. The crew is about 4 hours now from waking up. Flight controllers continue to prepare messages for uplink to the crew, and those messages will be going up in a couple of hours from now, and expected to be on board just before the crew wakes up. This is Mission Control Houston. Our next television event will be a replay of Flight Day 2 activities. That replay is scheduled for 1 day, 14 hours, 55 minutes mission elapsed time. That translates to 9:30 Central Standard Time this evening. This is Mission Control Houston. A reminder coming up in about an hour is a replay of Flight Day 2 activities, including deploy of the CENTCOM 4 F5 satellite for the Navy, and some in-cabin views of several of the secondary payloads, including the fluids experiment apparatus and other secondary payloads aboard this flight. This is Mission Control Houston at a mission elapsed time of 1 day, 14 hours, 28 minutes. We are standing by for a replay of Flight Day 2 activities of the flight of Columbia and STS-32. That replay will be upcoming in about 30 minutes from now. This is Mission Control Houston. Standing by in about 10 minutes to replay the Flight Day 2 activities occurring on STS-32 Columbia. Some of those include the deployment of the CENTCOM 4 F5 communication satellite for the Navy, and some in-cabin views of the crew at work. And that replay will last for slightly more than 8 minutes. This is Mission Control. Our next television event will be coming up very shortly. It's a replay of Flight Day 2 activities aboard Columbia. This is Mission Control Houston, back live here at the Johnson Space Center following that replay of Flight Day 2 activities aboard Columbia earlier today. Columbia now closing in on completion of orbit 26 as it passes over Brazil. Still chasing the long duration exposure facility seen just ahead of it on the orbital tracking map. As Columbia completes orbit 26, the LDEF just beginning orbit 32,398, as evidenced by the yellow 4-digit number directly above the shuttle's orbital number. Due to a limitation of the space, only 4 digits are used. Number 3 should be placed in front of the 2. Planning shift controllers here in the control center continue to review messages which will be uplinked to the crew in time for them to get those when they wake up. That is now scheduled for about an hour and 52 minutes from now. Much of the crew's activities, once they do wake up today, will be working on several of the mid-deck payloads aboard Columbia. Also today, the crew will perform 3 maneuvers, putting it closer to LDEF in preparation for the retrieval on Friday morning. The latest take on the actual grapple of the long duration exposure facility is now about 8:48 a.m. Central Standard Time, Friday. The 3 burns which are scheduled for later in the day after the crew awakes, the times for those are still being addressed here in the control center. At crew wake up, Columbia will be approximately 522 nautical miles behind LDEF, closing on the spacecraft at a rate of 33 nautical miles each orbit. That, of course, will change after each of the burns, which are scheduled tomorrow. Currently at mission elapsed time of 1 day, 15 hours, 9 minutes. This is Mission Control. This is Mission Control Houston at a mission elapsed time of 1 day, 16 hours, 24 minutes. The planning team controllers are completing their wrap-up of their messages that are being sent to the crew. And at the same time, the Orbit 1 flight controllers are beginning to filter into the control center to take their routine 1-hour handover from the planning team. We're now about 34 minutes away from waking the crew of Columbia to begin their Flight Day 3 activities. And our next television event will be a change of shift briefing with off-going planning team flight director Bob Castle. That briefing is scheduled for 12:30 a.m. Central Standard Time, January 11th, in Building 2, Room 135, here at the Johnson Space Center. Any news media interested in taking part in that briefing should contact the JSC News Center at area code 713-483-5111. This is Mission Control Houston at a mission elapsed time of 1 day, 16 hours, 39 minutes. Columbia now beginning orbit 27. Correction, orbit 28. We're now about 20 minutes away from waking the crew to begin their Flight Day 3 activities. Planning team just sent the first page, or tried to send the first page of the uplink package on the text and graphics system, and that proved no joy. The indication from the instrumentation and communications officer was that the first page jammed. The flight control team will wait until the crew wakes up and discuss any further action to unjam the tags and possibly try again later this morning. In the meantime, all messages will be uplinked on the teleprinter. As mentioned earlier, there are 3 burns scheduled today, which will reduce the distance between Columbia and LDEF as Columbia continues in its quest to track down and snare the satellite. The first burn, NH1, the time of ignition on that burn will be 2 days, 2 hours, and 3 minutes mission elapsed time. That translates to about 6:38 a.m. Central Standard Times, and that will be an orbital maneuvering system burn, OMS burn. The second burn, the NSR burn, TIG time on that is 2 days, 3 hours, 45 minutes, or 10:20 a.m. Central Standard Time. That also is an OMS burn. The third and final burn on Flight Day 3 is the NC4 burn. TIG time on that is 2 days, 4 hours, 43 minutes, or 11:18 a.m. Central Standard Time, and that will utilize the aft reaction control system aboard Columbia. In other news, good news related to the payload deployed yesterday, the CENTCOM satellite. At 10 p.m. Central Standard Time tonight, the perigee kick motor apparently successfully fired. Tracking data looked good, however, acquisition has not yet been obtained, but the payloads officer confirmed that the tracking looked good through Hughes. And following that burn, CENTCOM should be in a 164 by 10,433 nautical mile orbit on its way to a operating orbit of 22,300 miles, which is geosynchronous orbit. We're now 16 minutes away from waking the crew. This is Mission Control. This is Mission Control Houston. Loss of signal through the tracking and data relay satellite west. We will pick up communications with the crew on the western satellite in about 7.5 minutes.
In Columbia, the morning mail's on the teleprinter. We'd like you to take a look at tags. We had indications that it jammed when we sent up the first messages to it today.
And that was the first thing I saw when I woke up this morning, little jams right in the tags. I'll do what you tell me.
Okay, Marcia, we're not looking for you to do anything just yet. Go ahead and take care of the rest of the work you got to do, and we'll get back to you about tags.
Okay, well, I can clear the jam now if you want.
Marcia, we don't have any other tags traffic right now, so you can press ahead with other activities. We'll get back to you on clearing the jam.
This is Mission Control Houston. The next television event, a change of shift briefing with off-going planning shift flight director Bob Castle. That was scheduled for 12:30, and that briefing has been canceled.
Columbia, Houston. The planning teams enjoyed working with you this morning. We're going to hand you over to Orbit 1 now, and we hope you have a great day. Columbia, Houston. The planning teams enjoyed working with you this morning. We're going to hand you over to Orbit 1 now. Frank will be talking to you for the rest of the day. Hope everything goes great.
Okay, thanks a lot. See you tomorrow.
Columbia, Houston, good morning.
How you doing today?
We're doing great down here, and we're happy to see that y'all are doing so well. The whole world's impressed. We'd like you to take a look at stars in slots 2 and 3 in the table and go ahead and align on stars 41 and 88.
Okay, we'll do that. 41 and 88.
This is Mission Control Houston. 1 day, 17 hours, 41 minutes. Mission elapsed time. Columbia has just passed over the northeastern coast of Australia and is out over the Pacific Ocean now. They're trailing the long duration exposure facility by about 495 nautical miles. They gain 33 nautical miles per revolution, and that will be the case until later today when we do 3 burns, which will set the stage for the final closure and we hope capture of the long duration exposure facility. Those burns, height adjustment and a burn called an NSR and then NC4, those will be taking place later in the morning. For the most part, they'll be taking place on the Orbit 2 shift. And the times for those, NH1, 6:38 a.m. Central, NSR, 10:20 a.m. Central Standard Time, and NC4, 11:18 a.m. Central. The planning team has gone off console, the Orbit 1 team here. During the handover between planning and Orbit 1, we got a good summary of the vehicle, and the summary is good. They have clean inertial measurement units.
Columbia, Houston.
We're standing by to acquire forward link through TDRS. At the moment we have a return link, no forward. We'll try to lock up comm, and then Capcom Frank Culbertson can talk to the crew. Meanwhile, a quick summary, good inertial measurement platform, all mechanical, hydraulic systems aboard Columbia in good shape. They're using up cryogenics and other fuels at expected rates. Weather is good in the continental United States for the 3 shuttle landing sites. IMAX has 7 opportunities this morning for Earth views. We'll be going into a gravity gradient posture in orbit, which means the shuttle will be going around the planet in the same orientation relative to the Earth. The windows will be facing south because most of the IMAX targets are south of the ground track, so that the crew will have a good eyes view toward the IMAX targets. Otherwise, not much to report. The crew in their post-sleep timeline, they're fixing breakfast, taking some calibrations of the optical alignment sighter, other household chores such as that. And at 1 day, 17 hours, 45 minutes, this is Mission Control, Houston.
Hey, Houston, Columbia.
Columbia, Houston, how do you read now? Columbia, Houston, how do you read now?
Roger, we got you loud and clear now. We got the IMUs lined, and we're wondering if you needed numbers.
Stand by on that for a second. We are having trouble with TDRS forward link, so we may have some intermittent dropouts here. We do want you to go ahead and get started with the water dump as soon as you can, so we can have it complete by the time we have to go to gravity gradient.
Okay, we'll put that in work.
And Dan, we have all the data we need. Thank you.
It's Mission Control, Houston at 1 day, 17 hours, 57 minutes. Mission elapsed time with a reminder our next television event. The scheduled briefing with Bob Castle, the off-going flight director, has been canceled. Meanwhile, the temperatures on nozzles A and B aboard Columbia have begun to rise. They're up to 132 degrees Fahrenheit right now in preparation for a supply water dump that'll be upcoming shortly. Also, there's been a little interest expressed in this morning's wake-up music. The story behind the song is that David Lowe loves to hum when he's in the water tank preparing and training for extravehicular activity. The suited runs that all astronauts do over there often are long and involve a lot of work, and one of the ways David stays in tune with what's going on is to hum. He loves to do that, and one of his favorite songs is the Banana Boat. So the EVA training people here in Houston put together this song and had it recorded and gave it to the Capcoms, and that's why it was played this morning. We've also gotten an indication from the CENTCOM people that they had a good transfer burn, and the last numbers we had showed CENTCOM in a 164 by 10,433 nautical mile orbit. That's first step and first leg up on CENTCOM's way to geosynchronous Earth orbit. Also, when we cross the equator here, LDEF, about a little more than a little less than 500 nautical miles out in front of Columbia, will enter its 32,400th orbit of the Earth. Columbia will begin orbit 29.
Columbia, Houston, we're with you through TDRS East now, and I have a few flight notes that we were unable to tags up whenever you've got somebody who can copy.
Okay, stand by. Houston, Columbia.
Go ahead, Columbia.
I can copy those flight notes now if you'd like.
Okay, Jim, thanks. First one has to do with today's AC utility outlet usage. At an MET of 1 day, 19 hours, we'd like to plug AFE into A15 for those sessions at 19 plus 00 and 20 plus 30. And that'll allow using MO13Q for the photo floodlights for the FEA activity.
Yeah, Steve, just a minute. Or Frank, sorry. Frank, I copied it. 1 day, 19 hours. We'll plug AFE into A15 AC outlet, and the rest of it I didn't get.
Roger that. And that'll also apply for an MET of 1 day, 20 hours and 30 minutes. And the reason for this is to allow the use of MO13Q for the photo floodlights for the FEA activity. And then at 2 days, 1 hour and 25 minutes, we'd like to use that same A15 panel to power the photo floods, so you do not have to unplug the Spock.
And Houston, Columbia.
Go ahead.
Okay, we copied 1 day, 19 hours. We'll plug AFE into A15 AC outlet, and also at 1 day, 20 hours, 30 minutes, we'll do the same thing, and that's to allow the photo flood to be used in MO13Q for FEA, and at 2 days, 1 hour, 25 minutes, we'll plug the photo flood into A15.
That's affirmative. And the next message has to do with the change to SPS-1 on the timeline that we talked about earlier, SPS ops.
Frank, is that on the teleprinter?
It's in the execute package on the teleprinter. That's affirmative. We had recommended moving SPS ops earlier than scheduled up to 1945, and instead of doing that, we'd like to move it later to 1 day, 22 hours even, and that'll make the deactivation closer to 24 hours after activation.
Okay, on line 49, page 1 of 2, message 9, we'll change it to read 1 day, 22 hours even for SPS ops.
That's affirmative. And the next one has to do with page 3-22 in the payload ops checklist.
Okay, stand by. Houston, Columbia.
Go ahead, Jim.
Okay, the payload ops checklist is in hand.
Roger that. On page 3-22, you have a list of times for recording disturbance observations. After DSO 476, we'd like to add a new line for the NH1 burn when you're ready.
Okay, ready.
The planned MET is 2 days, 02 hours, colon 03. Event NH1 burn. Same blanks to fill in. And record time will be 2 minutes. In addition, we'd like to change the NC3 burn to an NC4 burn and the time to 10 minutes. Disregard one, make that 0 minutes.
Does the MET of that change, Frank?
It probably will, but not for now.
Okay. We'll make NC3, we'll change it to NC4, the time of 0 minutes, and we'll add on 2 days, 02 hours, 03 minutes, the NH1 burn, and we'll fill in the same actual MET start time, and it's the 2-minute record time.
That's affirmative. And the planned in MET for the NSR burn, while we're talking about this page, is 2 days, 4 hours, and 10 minutes.
west. We're getting a pretty good show of the supply water dump, and I got distracted.
Roger that. The planned MET for the NSR looks like 2 days, 4 hours, and 10 minutes.
Okay, the NSR, 2 days, 0410.
Roger, and on the next line, the newly titled NC4 burn will be 2 days, 4 hours, and 43 minutes.
Okay, 2 days, 4 hours, 43 minutes.
Affirmative. And as you probably noted in the changes to the flight plan, the times for all those DSO 476s slip.
Yeah, we got that.
And the last information I have to pass, the title of the message that was ready to be sent next when the tags jammed was the tags jamming questionnaire. So whenever you're ready to copy, we'll send those up orally if you'd like to, at some point later, spend some time troubleshooting.
Okay, we'll give you a call in a couple seconds when we got a few bullets.
Roger, we'd like to make Marcia's IMAX activity a much higher priority than this, and we'll work on the tags as she has time.
We've already done that, thanks.
Columbia, Houston, we've got about 2 minutes till LOS. We'll have no AOS on iOS this time, so we'll see you on Tidris West, AOS at 18 plus 57.
We were waiting for the world-famous LOS-IOS call. We'll see you there.
That's on the next pass.
It's Mission Control, Houston, 1 day, 18 hours, 48 minutes. Loss of signal through the eastern satellite will reacquire on the west in 8 minutes, 54 seconds.
Columbia, Houston, we're back with you through Tidris West.
Loud and clear, Frank.
You're the same.
And Houston, do you need to know the time that we entered free drift?
That'd be good to know, Jim.
Okay, 1 day, 18 hours, 54 minutes, and 30 seconds. And at that time, the roll arrow was minus decimal 005, pitch was plus decimal 001, and yaw was plus decimal 067.
We copy that, Jim, and thanks for the data.
And Houston also have the plus X Coascal data for you.
Roger, Dan, go ahead.
Okay, the plus X Delta BIOS was 1.06, and we updated it at 1 day, 18 hours, 16 minutes, and 25 seconds.
Roger, and we thank you for that data also. Columbia, Houston, one question on the Coascal.
Go ahead.
Actually, it's two questions. One, we'd like to know who performed the cal, and also how the visibility was out the front window.
Okay, Wex did the cal, and we didn't have any trouble seeing the stars. The front windows, same old thing. When the sun is shining at the correct angle off of them, they look pretty opaque. But when you're looking other than at low sun grazing angles, they don't look very bad at all.
Roger, thanks.
Houston, Columbia.
Go ahead, Columbia.
Yeah, we got looking at your earlier request on outlet allocation for AFE and the photo floods, and I guess a couple comments on that. First of all, AFE doesn't reach 015, and 015 and MO13 are on the same circuit breaker. So I guess I don't understand what difference it makes which one we have plugged where. We have better luck with an A-15 because then we can go down either hatch, and I think we can pretty well cover anything we want to do on the mid-deck, doing it that way.
Dan, just for clarification, you are talking about panel Alpha 15.
Excuse me, yeah, I'm at A-15, I'm sorry.
Just stand by one on that. Columbia, Houston, we understand your question, Dan, and we're looking at it a little bit more. We'll get right back to you.
Okay, and we understand the desire not to have the photo floods and FEA on the same circuit, and we're cognizant of that.
Roger. Columbia, Houston.
Go ahead, Houston.
Dan, we concur with your suggestion on plugging in the utility power. However, we do have a question. We had thought that we had plugged AFE into A15 on day one, and we were wondering if the reason it wouldn't reach now was because it was pulled out of the locker.
And Houston, we never had it plugged in A15, and we still have it in the locker, although when we've used it, we pulled it partially out for cooling.
Roger, so we understand then that it never has reached A15.
Yeah, and that's correct. The procedure in the payload ops checklist 1-3 has MO13Q from day one. Houston, Columbia.
Go ahead, Columbia.
Okay, on the teleprompter messages, updates to the flight plan on line, page 2 of 2, line number 9. Can you verify that you want that Ohms burn moved to 2 days, 3 hours and 45 minutes? It kind of seems it would fit in better at 2 days, 4 hours and 45 minutes, the way everything else is falling out.
The 2 days, 3 hours and 45 minutes was the prep time. Right now the TIG is scheduled for 2:04:10, and we are looking at changing it somewhat.
Okay, thanks.
Columbia, Houston.
Go ahead.
We'd like to take the star trackers back to track, please.
Roger.
Columbia, Houston, I have some IMAX target of opportunity data for Marcia whenever she has a chance.
Okay, just a second.
Okay, Frank, I'm ready for your targets of opportunity.
Roger, it's only one, Marcia, and it's at an MET of 1 day, 20:13:11. It's a sandstorm, and it should occur right after your Western Sahara opportunity on Rev 30 at approximately 17 degrees north and stretching between 14 and 16 degrees east, north of Lake Chad. They suspect it will be clearly visible and fairly dramatic, and we suggest windows 7 or 8 for both shots. It's a high priority, orbit 30, oblique, lens 40, and that should complete the data.
Okay, we'll try and get it for you.
Thanks.
Mission Control, Houston at 1 day, 19 hours, 44 minutes. Mission elapsed time. Columbia, trailing behind the long duration exposure facility by a little less than 500 nautical miles, is now on orbit 30 about the Earth. LDEF is on its 32,401st orbit. They're about to pass over Central America, both of the spacecraft. On the upcoming pass over Africa, we believe there's a good opportunity for a view for the IMAX camera system of what is described as a fairly dramatic sandstorm just east of a pass that had been previously scheduled over the western Sahara Desert. The sandstorm is raging north of Lake Chad, and we hope to capture that from orbit. Right now aboard Columbia, the crew has just completed changing out lithium hydroxide canister. They're also well into various procedures with some of the secondary payloads. Columbia's current altitude, 172 nautical miles. The team down here on the ground has been discussing tweaking one of the times for an upcoming maneuver, part of the rendezvous catch-up for tomorrow's arrival at the same spot in space as LDEF will occupy. The burn is called NSR. Right now it's scheduled at 2 days, 4 hours, and 10 minutes, and the discussion is to move it up by about an hour and a half. What this will do is give us some additional tracking opportunities. The goal of the 3 burns that will be done today are to place the Columbia at a distance of about 40 nautical miles behind the long duration exposure facility for tomorrow morning, and at that distance then the final rendezvous catch-up burns would be performed and the final rendezvous procedures done that would cause us to get there and grapple the spacecraft a little after 8 o'clock tomorrow morning. The idea of moving this burn up an hour and a half is simply to allow for more expanded C-band radar tracking from the Earth, so that if we do end up, for instance, 50 nautical miles behind rather than 40, we would have a little advance warning of that and could make the proper tweaks. So the flight dynamics and navigation people continue to tweak the plan. We're still looking at it a bit, but we hope to tell the crew pretty soon that we're going to do that.
Columbia, Houston, we've handed over to Tidris East now. How do you read?
Loud and clear.
You're loud and clear also. Columbia, Houston, I need to give some words to Marcia. She doesn't need to reply, but if she can listen to a quick brief on this sandstorm, I'd appreciate it.
We're listening.
Roger, as you approach, it'll be south of your track and looking towards Lake Chad. The northern part of the area is clouds, and the sandstorm will actually be in the southern part between the clouds and Lake Chad.
Okay.
Columbia, Houston.
Go ahead.
Roger, we've got about 2 minutes until LOS. Before that, I have a couple of questions for you. One was whether you were able to see the sandstorm, and the other is due to the comm dropouts during post-sleep, we missed the cryo heater sensor check and just wondered if you could give us the results of that.
Frank will do that here shortly, and we'll tell you next time.
Roger that.
And we think we shot the sandstorm. We had a little trouble setting up for it, and we used the 60-millimeter lens because we had a little trouble with the 40. And so if you have another good call on that, we'd like to reshoot it.
Okay, we'll take a look and see whether we think it'll be visible next time around. Thanks, Marcia. In Columbia, Houston, we'll pick you up on Tidris West at 20 plus 35.
See you there.
And when we come back up, I've got some words for Bonnie to discuss an overlay issue that came up pre-flight when she's ready to copy.
Okay.
Houston, are you still there?
We got 1 second. See you on the other side.
Sensor check was good.
Thanks, we copy.
Loss of signal through Tidris East will reacquire in about 10 minutes through the western satellite.
Columbia, Houston, we're back with you through Tidris West.
Yeah, Frank, you're loud and clear, and Dan has got the borescope down in the underneath where the LIO canisters are. Bonnie is recording what appears to be water coming out of one of the humseps. We're going to take a look at it, maybe turn the humsep off, and we'll dump you the downlinks.
Okay, thank you.
And Frank, if you have downlink TV, I have it coming down.
Roger, we're trying to set that up now. Columbia, Houston, we're in blockage for TV right now. We're working on when we'll have it available.
Okay, we'll send down video when you're ready.
Roger, you are recording it, right?
Affirmative.
Houston, Columbia, if you concur, we'll turn off the humsep. We're recording it. We can dump you that later, and then we'll get it cleaned up after turning off the humsep.
Stand by one, please, Jim.
Houston, are you still there?
That's affirmative. We're discussing whether to turn them off right now or not, Jim. Stand by one, please. Columbia, Houston, since we can't get the downlink, can you give us a little more description of what you see? Is it an active leak, and do you have free water?
Yeah, it looks like a couple or three bubbles every couple of seconds are coming out.
Can you tell where they're coming out?
Okay, it looks like an exit port for the humsep, and there's a number on it, 990 Victor 61 Papa is Tango Papa is the number.
Is that 6-1 Tango Papa or 6 Tango Papa?
61 Tango Papa, and it's coming out of a screen that is gold in color.
Roger that.
And it's a domed screen.
Copy that. Columbia, Houston, we'd like you not to change your configuration for the moment while we talk about it in the back rooms. We think we understand where it is now. However, we would like to make sure you have a good recording of it. We won't have video for about 20 minutes.
Okay, we copy that. We'll stay in this configuration, and we'll double check to make sure we're recording it.
Thank you.
And Frank, Dan says they found it when they were changing the LIO.
Roger, we understand.
Inside the container was wet.
Understand the outside of the container was wet.
Frank, the inside of the LIO container was wet, so we pulled out a couple of the trays to see how far it extended. We ended up pulling out all of the LIO and found the inside of one wall wet. We dried it down and then took the fiberscope out to look at the front wall. The back wall of the outside was dry, and that's when we saw the humset putting out drops.
Roger that, and you have a go to start cleaning it up if necessary.
Frank, we don't have the LIO container out yet. We'd need to pull that out to start the cleaning up.
Understand. Columbia, Houston, you have a go to pull that LIO canister so you can clean up the water, and also a go to switch humseps from B to A.
Okay, it's in work.
It's Mission Control, Houston, 1 day, 20 hours, 44 minutes, mission elapsed time. When Columbia came up and we reacquired over the western satellite, the crew reported that during the changeout of a lithium hydroxide canister on the last rev, they had noticed some water, some dampness down in the bay where the lithium hydroxide canisters are located, and they believe that that is coming from an exit port on humidity separator B. They've been given the go to change over to humidity separator A. From what pilot Jim Weatherby said, it does not sound like a great deal of moisture. He said 2 or 3 drops are bubbling out every couple of seconds. The crew will wipe it down, and we're going to take a look at it as soon as the orbiter comes out of KU band blockage. We'll bring down some television that they've taken with the fibroscope or borescope that they stuck down in there and then taped, and they'll dump that tape to us as soon as the orbiter gets in the right attitude for us to bring it to Earth. We believe that television will come to us at about 1 day, 21 hours and 5 minutes, and we'll keep you updated on that. For those following and who might have this reference work available, there's a standard National Space Transportation System reference book in Volume 1 entitled Systems and Facilities. If you turn to pages 363 through 366, you get a pretty good series of diagrams of where we're talking about in the floor of the middeck where these systems are. Again, this is humidity separator Bravo, and they're switching over to humidity separator Alpha.
Columbia, Houston, with a question about the water leak.
Go ahead, Frank.
Roger. On STS-32, when they had a similar problem, they had a full sheet of water on the front of the LIO container box. Do you have that much, and have you reached the point where you're going to need to go to vacuuming?
Frank, I haven't been able to see that much, but they're just taking the box that holds the LIO canisters out, so we'll call you when we know something.
Oh, okay, thanks. And they saw the water on the outside of the front edge of the leading edge of the box.
Okay, they first saw the water on the aft end of the LIO canister box.
Inside or outside?
It was the outside of the box, and Dan says he can feel down about 2 inches so far and can't feel any water.
Okay, thanks.
I'm sorry, Frank, they've corrected me. It's on the inside of the box that they saw the water.
Understand, on the inside of the box, on the aft side?
That's correct.
Roger.
And the box they're talking about is the container that holds the LIO canisters. That container has to be removed in order to get to a position where you can reach and see around the humidity separator, which is a fairly large contraption that has a variety of hoses and exit ports and piping leading in various directions. There are 2 of them down in this bay. A similar problem cropped up on STS-27, and the crew mopped up the water, the excess water, and also used the water vacuuming system that they've got aboard to clean it up. This Mission Control, Houston, with a reminder, we do hope to bring down some television from Columbia, some unscheduled views of the work they're doing down on the middeck to try to sop up some water and find the source of it in humidity separator B. This should be a videotape replay from the orbiter. If it comes down via the camcorder, our viewers around the country should see this in standard broadcast signal. It's possible that it won't, however, and in any event, we will be switching our satellite feed and turning the satellite around to the ground terminal at White Sands so that we can receive the television The net effect of that is that commentary from Mission Control will not be available on NASA Select Audio, but is, as always, satellite fed on Mission Audio. As soon as the downlink is concluded, we'll of course switch the satellite back to Houston, and our listeners will again be receiving the commentary on NASA Select. We apologize, but that's the configuration we're in for this mission.
Columbia, Houston, we have video now. We're showing a test pattern. We're ready to start looking at what you've got. Columbia, Houston, we've got the video test pattern now. We're ready to start looking at what you've got and confirm you're using the camcorder on this.
Okay, we copy, Houston. It's coming down. And it's VTR.
Copy VTR.
Okay, are you getting it?
Okay, we're just starting to get it.
Houston, Columbia.
We have a good picture now, thanks.
Okay, and you've got the HUMSEP on the left and the water coming out on the right.
Roger that. Columbia, Houston.
Columbia.
Go ahead.
End of downlink.
Roger, that was excellent photography of quite a bit of water. We thought it looked like we probably need to get going with the free fluid disposal. Do you concur with that?
It's already in progress. We're trying to get the volume out right now so we can get at it.
Roger that. And have you noticed any similar leakage from HUMSEP A?
Not at this point. We'll take a look at it when we can get down under.
Roger. And Columbia, do you have anything live you would like us to look at now?
Stand by. Houston, Columbia.
Go ahead.
Stand by. We need to reconfigure the CCTV.
Roger.
It's Mission Control, Houston in 1 day, 21 hours, 11 minutes mission elapsed time. Just concluded a downlink from Columbia, some videotape they sent us that they shot a few moments ago as they were looking into the problem with humidity separator B. They've already switched over to the A separator. Mission Specialist Bonnie Dunbar reported that at the moment, to the extent that they have insight into the operation of the A side as they're removing equipment to get a better look, they don't see any water coming out of the unit that they're now using. The B unit is off. The ECOM officer here in Mission Control said if that was the case and we could confirm that, then we can probably figure out what the plumbing is doing on humidity separator B and figure that out in fairly short order. We believe we may be getting some more television via the closed-circuit TV system on Columbia in a few moments, and if so, we'll let you know.
Houston, Columbia.
Go ahead.
With regard to the other scheduled activities, we're going to have to delay a little bit on the FEA.
We understand. And Columbia, Houston.
Go ahead, Houston.
Roger, you're probably already planning to do this, but based on 27's experience, we thought it might also be a good idea to take a look in MD44F, where the temp controller is, and also in volume H or volume G, and see if the water's migrated that far aft.
Okay, we'll do that.
Disregard the volume G for now.
Those volumes referred to by Capcom Frank Culbertson are areas beneath the floor panels in the middeck, and each one has got its own designation, volume H, G, and etc. On STS-32, they had free water floating out into some of those volumes because of a similar type of problem. To get to those areas involves unscrewing the floor plates. The floor plates are basically stainless steel. Can be quickly detached and removed so that the crew members can look down inside. On STS-27, some of the water from the area that the crew is looking in now had migrated aft to other areas. Of course, water in zero gravity forms bubbles and floats around as water globules due to surface tension holding it together. And on STS-27, the routine was to soak it up with towels and paper wipes at hand, and there also is a free water collection wand, as it's known. It's essentially a vacuum cleaner on board the ship that can suck up free water.
Houston, Columbia.
Go ahead, Columbia.
Okay, we got the Lyle canister storage container about halfway out, and it looks like on the forward side there's a sheet of water, maybe about a quarter of the way up. On the starboard end, I can't really see anything because there are a lot of ribs, and on the aft side, there's just a little bead of water around the bottom edge, and we're getting ready to connect, waiting for the temp to come up to connect the free water disposal line.
We copy that. And, that was on the outside of the box that you saw that?
Affirmative.
Thank you.
It's Mission Control Houston, now 1 day, 21 hours, 19 minutes. The ECOM officer reports the crew now has switched on the free water disposal system. So the vacuum cleaner is sucking up water now. Dan Brandenstein, the commander, reported they had a few minutes ago pulled the container that holds the LiO canisters about halfway out. They noticed a sheet of water on the front side of it and a few beads of water, as he described it, on the back end.
Houston, Columbia.
Go ahead, Columbia.
If you're still configured for TV, we'll send you down to mid-deck.
Go ahead, we're ready. Columbia, we've got a good picture.
Okay. Okay, there's not a lot of activity right now. We're waiting for the nozzle temperatures to come up.
Copy that.
And Frank, what you can see, you probably can't see it very well on TV, but right along the leading edge here, starting about where the light is now, the water comes up about a quarter of the way, just a little bit below where the floor line now is, and it goes back over here, and here it comes up to about the floor line. It's just a sheet of water, as you indicated. It was like on 27 on the front. Around the end here, we can't see anything, but on the back side, there's a little ridge along the bottom, and you can just see that there's just some water there. Looking down into the bilges, every once in a while you can see a little glob of water down there, and until we get this out, it's going to be kind of hard to tell because we can't get that good a view down past this canister right now.
Roger, do you think the fact that it's coming over the forward and the aft edge indicates it's pretty wet on the bottom?
Yeah, it's kind of hard to tell. I didn't get a chance, kind of steering the borescope, I didn't get a chance to see what that was showing. How we found it, we were in here getting a LiO canister out, and we'd completed the top row here, and we were going to remove it and go down to the bottom row, and that's when we saw some water, and it was just on the back edge, where the light is now, of this container. And then we took this one out, and it seemed to be all along the back edge, and until we started pulling this out, we couldn't see any water down the side. The way Columbia is configured, there was around the edge, when this was in place, there was a Teflon kind of a seal that we took out. It was just kind of held in with aluminum tape. And then on the front edge here, there was just a teeny little crack. I could peer down. I could see the HumSep and that screen, and So I took the borescope down, and you've seen everything after that.
Roger that. And can you get to MD44F where the cabin temp controller is and look through that direction? Under your left foot there?
Yeah, I went down there and I couldn't see a thing. Right around the looks like it's probably the inlet pipe. There's some aluminum covered, looks like ducting. There was a little condensation on the outside, but it wasn't globules of water. It was just like the pipe was sweating.
Okay, thanks. And they say that's normal.
And
go ahead, Columbia.
Yeah, you can probably see Dan's in the process of sucking the water out now using the contingency thing.
Roger that. We're watching.
Do you have any idea how much flow rate this will suck up?
Stand by one. Columbia, qualitatively, we think it'll be a pretty slow process. We got about 1 minute till Tidris East handover.
Okay.
And Columbia, we also need to turn off the master MADS because it's down there.
Roger.
And master LEX is off.
Copy, master MADS off.
Temporary loss of signal as we hand over between the western and eastern satellites. We are taking television from the middeck of Columbia. As we look over the crew's shoulders, Commander Dan Brandenstein was in the process of sucking some water out of an area where the humidity separator apparently has been leaking.
Columbia, Houston, we're with you through Tidris East now, and we've got live TV again.
And Houston, Columbia, looks like I sucked up most of the water on this canister that I can. We're going to try and pull it out now and see what's underneath.
Roger that, Dan.
Now 1 day, 21 hours, 35 minutes mission elapsed time. Columbia out over the mid-Atlantic Ocean, and within the middeck of the orbiter, we see Commander Dan Brandenstein now looking down through the crack in the floor as they're slowly pulling out the container that holds the LiO canisters. The crew members are being very careful as they pull this container up to make sure that they have mopped up all the water that they can see. And that tube you see near Brandenstein's right hand is connected to a wand, a vacuum wand. And as they expose more and more of the container, Brandenstein is making sure to vacuum up the water droplets. Those droplets are sucked into plumbing that ultimately leads to a dump nozzle, and so the water is going directly overboard as they do suck it up. It's hard for us to know exactly how much water they have vacuumed, simply because the amount that travels through the hose is mixed with air, and so it's not easy to get a good reading of the volume of water that they're pulling up. The idea, of course, here is present on the commander's mind is to make sure that they don't introduce any more free water into the cabin itself than is necessary. Once they have carefully pulled this container out, they then will be able to look down into the cavity where the humidity separator is that apparently has been leaking, and that's humidity separator B. They switched to the A side about a half an hour ago.
Go ahead, Columbia.
Yeah, hopefully, well, I'm sure you're watching the temperatures on the waste nozzle.
We're watching, and they're okay right now. They're running about 120, and we're also watching your actions. You're doing a good job.
Is there a number where you want us to pause for a while and let them heat up again?
Say again?
Is there a lower temperature that you want us to pause dumping for a while and let it heat up again?
We're checking. I'll be right back with you.
Yeah, in case we go LOS. Okay, thanks.
And Columbia, Houston, it's hard for us to tell from the picture how much is on the bottom of the box.
Yeah, they say there's not much on the bottom.
Roger that. Columbia, Houston, a minimum temperature of 60 will give us plenty of margin, and we don't expect you to get that low.
Okay, thanks a lot.
Columbia, Houston, we see a CCTV over temp. We were just wondering if you still had the camcorder plugged in somewhere.
We don't have any camcorders in the CCTV loop. We had the VTR on.
Roger, that explains it. Columbia, Houston, we can tell Dave practiced that with his garage pipes not too long ago.
Roger, Houston.
That was a below-the-belt shot from Capcom Frank Culbertson. David Lowe, among many people here in Houston, suffered damage during a freeze the weekend just before Christmas, and all over the city of Houston, pipes were bursting, and David was one of those who had to cope with that kind of situation.
Columbia, Houston, we can't tell very well from the video what you're seeing. Can you give us a little bit of a description, what you got in the bilge?
Okay, Frank. I'll kind of start on the water tank up here. There are a few globules, and on the side of the wet trash stowage, there's one big glob. And then down along the side of the wet stowage, there's some more. Then on the deck and along these cables, there's some big globs. And then also on the humsep, there's some big globs. A grand total probably of a quart, if you probably summed it all up, and that's a pretty rough guess probably. So we're going to start sucking it.
Roger that. And Columbia, Houston, now that you should have a good view of humsep A, is there any evidence of any leakage from that one?
No, he put his hand in front of the outlet, and there's no water coming out of humsep A.
Roger. Thanks, Jim. It's good news.
Houston, Columbia.
Go ahead.
So we're going to need a few more hands, so we'll be terminating TV. We'll record the rest.
Roger that. And thanks for what you gave us. It helps us a lot in evaluating the problem.
You're very welcome.
Columbia, Houston, with a question.
Do you want any particular attitude?
I think we just want you to stay where you are right now in the gravity gradient.
Okay.
And I have a question concerning your filter cleaning from yesterday.
Go ahead.
Roger. One thing they found on Atlantis was that there was quite a bit of blue lint in the pitot tube, which they think helped cause the leak on that flight. And we were wondering if you saw an excess of lint during your filter cleaning yesterday or any moisture on any of the filters.
Okay, stand by.
It's Mission Control Houston. We are now originating our signal from Johnson Space Center again. NASA Select Audio now back on the bird. We've just concluded a downlink from Columbia. As we were looking over the crew shoulders, they're in the midst of cleaning up some water that apparently was introduced into the floorboards of Columbia by humidity separator Bravo.
Frank, there was no water on the filters. There was some lint. It wasn't blue, but kind of gray.
Roger. Did it seem to be excessive or a normal amount?
Normal.
Copy that.
References they're making here are serving to compare the situation that Dan Brandenstein and his crew members are seeing to what we observed and what Hoot Gibson and his crew experienced on STS-32. They had a similar problem aboard the Atlantis with some free water also introduced into that volume by the humidity separator. Also, Mission Control Houston, we will be replaying the video that we took from Columbia. We're going to edit it down since that comprised something on the order of 40 plus minutes. And we'll begin that replay at about 40 minutes past the hour. Loss of signal through Tidris East will be coming up in 4 minutes 50 seconds. We're as yet unsure if we may take television from Columbia on the next orbit, although what is certain is the first 20 to 30 minutes of the next Tidris pass over Tidris West, as we are in the gravity gradient mode, will be in blockage. So if we did take TV, it would be at least a third of the way through the next Tidris pass.
Columbia, Houston, you might want to write this down, but we've already had AOS, IOS. We expect LOS, TDRS East in about 4 minutes, and we will probably pick you up on the west side. AOS, TDRS West at 22:12. However, we will continue with IOS for another 6 minutes and 40 seconds until LOS.
Sounds pretty fishy to me.
Trust me.
Consensus here in Mission Control is that Capcom Frank Culbertson may just have set a record for excessive use of acronyms, but essentially what he's saying is we're going to exit Tidris East and continue coverage with Columbia through the Indian Ocean Station. And on another subject, the rendezvous and navigation people have determined that due to the distance between Columbia and LDEF, after the NSR burn that will take place at 2 days, 2 hours, 40 minutes today, the LDEF range will have dropped to about 280 nautical miles, and it may then be visible as a first or second magnitude star directly ahead of the orbiter, about 18 degrees above the horizon. Analysis suggests that LDEF may be located low in the commander's windows, W2 and W3. Best observing times are near sunset, and we, in a flight note that we'll send up to the crew a little later, will invite any comments on the visibility of the long duration exposure facility or any characteristics they may be able to observe. We've not yet voiced that note up to them, but we will, and again, there are several hours before those conditions will become available. Acquisition of signal through the Tidris Western satellite. Meanwhile, on NASA Select, we continue to replay some scenes from the last rev. The voice you're hearing now is on mission audio, and the audio that goes along with that replay, of course, is on NASA Select.
Columbia, Houston, we're back with you through Tidris West.
Loud and clear.
You're loud and clear also, Jim.
We've just concluded a replay from the scenes we got from Columbia on the last pass through the Eastern satellite. We're now live with you. We've just reacquired through the West, and we're at 1 day, 22 hours, 13 minutes.
Columbia, Houston.
Go ahead.
Roger, we'd like to get a status of what you found so far and where you are. And also, is there any chance that you could fix a mount for the camera so we can follow your activities?
Okay, we can handle that. And Dan is still vacuuming, and he's moving aft now.
Roger, have you found water in any of the other volumes?
He's still mostly working in this one volume. I guess it's possible.
Roger that. And also,
probably not a whole lot.
Copy that, Jim. And also, we're discussing down here the fact that we're probably going to want to make a daily check on HUMSEP A and have ready access to it in case it does start to exhibit any leaks. And wondered what your thoughts were on either loosely reinstalling the LiO box or stowing it somewhere else if there is room.
Sounds like a good idea at first thought. We'll have to think about it a little bit more, though.
Roger that.
Houston, Columbia, we have mid-deck cameras for you.
Thank you. Columbia, Houston, we're still in blockage for the TV for about another 10 minutes. We also may have some comm dropouts due to teachers being off the tail for a little while. In addition, we just uplinked some compensations to your IMUs.
Okay, thanks.
It's Mission Control, Houston, 1 day, 22 hours, 30 minutes, mission elapsed time. Columbia is now past the eastern coast of Australia on orbit 31. We have, for the last 90 minutes or so, been involved in an unscheduled in-flight maintenance activity. Those are the kinds of activities that are always unscheduled. The crew discovered water down in one of the compartments below the middeck floor. The source of the water appears to be humidity separator B. They switched over to the other unit. There was indeed a leak that we could see on downlink television from that original humidity separator. We took about 30 to 40 minutes worth of television on the last teacher's pass from Columbia as we watched the crew mop up and vacuum up some of the water that separator had introduced into the cabin or into the compartment beneath the cabin floor. Commander Brandenstein estimated the total volume of water to have been about a quart, so that's not a great amount of water. It does become a little more problematic on orbit than it would in the 1G of Earth, however, because the water tends to float about in globules held together by surface tension, and that can be a problem when you've got a lot of electrical relays and equipment such as we do on a spaceship like the Columbia. But they've managed to contain it and appeared to be making great headway in cleaning it up the last time that we were able to look over their shoulders. The next event on NASA Select, we hope, will be some television from Columbia. We should go out of blockage of the Tejas satellite in a few more minutes, 4 or 5 minutes from now, and we hope to take television live from Columbia. We have altered our television configuration here on the ground so that we will be able to bring the signal to our viewers across the country uninterrupted and in NTSC standard broadcast format, which means both the television, the color television, and this commentary will be available on NASA Select. The next scheduled event on NASA Select television is, of course, the replay of Flight Day 2 activities that have been set for 05:30 a.m. Central. If necessary, we will defer that and do the replay at a more appropriate moment. We'll, of course, let the live television take precedence, and we'll let you know what the schedule calls for as we get closer to it. We're now taking live television from Columbia. We see Commander Brandenstein way down inside the compartment, which about an hour or so ago held the container in which are stored the lithium hydroxide canisters. It's down below that area that the humidity separators are contained or are located. The tube that's snaking down into the compartment with Dan is the water vacuum. The water that's swept up and sucked up by that tube is carried down some plumbing that eventually takes it to a dump nozzle on the side of Columbia, and hence overboard into space. This scene is in the middeck, right in front of the airlock, of course, and we're looking down from the middeck cabin to the middeck floor.
Columbia, Houston, we've got good video from the middeck now, and that's really an interesting shot.
We will on this pass have, for this part of the pass, have intermittent dropouts. The Columbia is orbiting the Earth in a gravity gradient mode, and the geometry of Columbia's KU band antenna to the western satellite will alternate such that we'll have a couple of dropouts here and there as we continue to take this live television from Columbia.
Columbia, Houston, we've got good middeck video now, and that's really an interesting scene. Columbia, it's a good thing those Navy guys have to go through Bilge Cleaning 101, isn't it?